All right, we should be ready to be live. Let me just check that the audio is loud enough. Should be loud enough. Now I just gotta finish setting things up on YouTube and we should be good to go. About chat. All right, and I think we are all set on YouTube as well. Great. All right, we're all good. Turn on live chat. Oh yeah, I forgot we invited Free. Let's see if he shows up. The microphone isn't great. It's not? When is the bonus Patreon tier opening? Potentially soon. Potentially soon, because I'm just finishing up some other projects. And then we should start. Once those projects are done, then we'll be starting probably. All right, let's talk to Brad Benavides. Brad, how's it going?
Hello?
Can you hear me all right?
Hey, brother. I'm doing good. How are you?
I'm doing all right. Do you think the Earth is flat?
No, definitely not. But I just want to say I don't really know if I'm a fan, but I do admire, who you are, and I've watched the TikToks for a long time, your lives. But usually they're not about if the Earth is flat or not. It's usually about Christ. Am I wrong?
No, they're never really about Christ, but sometimes they're about God. Anyway, I'm gonna let you go because you're not opposition here. But thanks for being here.
No.
All right, let's bring up another guest. Oh, there's Free. Yeah, let's do it. Free, welcome.
What's up?
Glad you could make it. Yeah, so we were gonna do like a math contest today or something like that. Or what were we doing? Do you remember?
You were trying to, well, we got into Flat Earth yesterday, even though it was a metaphysics live, but if you want, you could try to defend your globe.
So what kinds of observational evidence would you require?
For the shape of Earth or God?
Yeah, for the shape of Earth. That's the topic today.
Yeah, sure. Yeah, man, I would reference two things, man. I would reference water, and then I would reference airplanes.
Well, no, I'm asking what kind of observational evidence would you expect to see if the Earth were a globe that you don't see?
Oh, yeah. Well, if Earth was a globe, sure. Different speeds going from east to west and west to east, based off your rotation of Earth.
Why would you expect to see that?
Sure.
No, why? Why would you expect to see that?
Because if the Earth's rotating one way, 1,000 miles per hour at the equator,
yeah,
flying the opposite way, that's against the atmosphere, there should be a shit ton of shear wind.
No, but you're in the atmosphere. The atmosphere is moving with the Earth.
Yeah, but the atmosphere is moving with the direction of Earth. So if I fly the opposite, I should feel opposite.
Yeah,
rotation.
you'll fly the opposite at some speed relative to the atmosphere, and the atmosphere is moving in say one direction. So if you're flying in the opposite direction at say 500 miles an hour, relative to the ground or something like this, that means that you'd be flying 500 miles an hour, well, let's say 750 miles an hour, just to make the numbers easier. If you're flying 750 miles west, relative to the ground, if you take off and you want to go 750 miles per hour west, relative to the ground, that would also be 750 miles an hour west relative to the approximately stationary atmosphere, stationary with respect to the ground, I should say. And that means that you would feel wind stationary with respect to the ground. That would mean that you would expect to feel wind that is equal to 750 miles per hour, which is what you do when you're in an airplane.
Okay, so, okay, give me 5 seconds. Let me open my computer because this is going to be.
Yeah, sure.
All right, 1 second. All right, 1 second. You been doing all right though, Blitz, or what?
Yeah, I'm doing okay.
Besides taking away everyone's divinity by telling God's not real.
Yeah, let's go. Hail Satan.
Right. Oh, you're Jesus. All right. Oh, by the way, I wanted to show you my screenshot. I caught you and I recorded you saying energy isn't real.
Yeah.
I wanted to let you know
It's not
that.
well defined. It's not well
I asked
defined, to
3
be
other
clear.
physicists last night, and they thought you were a silly goose.
Okay. Then they're probably not familiar with Noether's theorem or how it applies in an evolving cosmology.
All right, cool. All right, here we go. I'm ready.
Yeah,
Sorry about that. Wait.
So like the way to think about this is like just think about being on a train, right? If the train is moving at 1,000 miles an hour to the east, and then you take your little RC plane and you take off in your RC plane going backwards at like 50 miles an hour, the RC plane from the perspective of somebody who's on the ground, not on the train, will still be moving forwards, just slightly slower. That's all that's happening with a plane.
That's all that's happening. All right, 1 second, Blitz.
I don't understand why like relative velocities are tricky.
It's not about it.
Oh, where'd he go?
All right, my bad. Sorry about that.
You're good.
All right,
Welcome back.
All right, right on, Blitz.
Why are you showing me your keyboard?
Been waiting to kick your ass on this topic for a while, bud.
Why are you showing me your keyboard?
Because you're about to get fried, Blitz. That's why, bud.
Okay,
I
I'm
got
sure.
the math because I got the math for you too, since you're good at math. You said.
Yep.
All right. 1 sec, bud. Okay, cool. So Blitz. All right. So, according to the paradigm, right, we are on a spinning globe, going about 1037 miles per hour.
Well, it's rotating once per day. The 1,037 miles per hour is at the equator.
Sure. Yeah.
For example, at the North Pole, it's 0 miles per hour. Right.
Yeah, I understand that, Blitz.
Okay.
Yeah. So.
It's just not really useful to use miles per hour to refer to rotational motion. But go ahead.
Do you want me to use radians or degrees? What would
you can use degrees per hour if you'd like. You could use
15 degrees per hour. You're rotating.
There you go.
All right,
sure.
Cool. Awesome. Right on, Blitz. So, a quick question for you, Blitz. If we're living here, and your ball is spinning, it doesn't matter what direction, right? And I'd say we're about what 35,000 feet an average commercial airliner goes. Yeah.
Yeah, roughly.
All right, cool. That means every 720 seconds, you'd have to count for about 1.2 degrees of curvature based off your radius value. Now, that's going 500 miles per hour, Blitz. So the only thing I'm referencing, 2 things. One is for you to claim that you go in relations to the speed of the rotation of the atmosphere, and you wouldn't feel that shear wind going 1037 miles per hour going to opposite rotation.
No, you'll just feel the relative velocity difference, right?
So let's do a quick word game real quick. Hey, Blitz, if I'm going 500 miles per hour, and I'm going with the Earth, will I need to catch up with the Earth, or is the atmosphere moving independent of Earth?
The atmosphere moves with the Earth, at least near the surface.
All right, welcome to Flat Earth, Blitz, because that's the way Coriolis states, all right? And number 2, Blitz, if we're going to
to be clear, Coriolis has nothing to do with the atmosphere.
No, it
Coriolis
does.
has to do with rotating reference frames. No, it doesn't.
Once your distance from the surface increases, your
no, it has nothing. It has nothing to do with the atmosphere.
It's okay. Don't worry. I have a perfect example. I was cooking some globies last night too.
I'm sure you were. Go ahead.
I was. Blitz, real quick, bud. So let's do some simple math. Blitz, if I'm running a track and field, Blitz, I have somebody in the outer field and I have someone in the inner field, Blitz.
Yep.
Can we both agree that one's got a bigger radius?
Sure.
Awesome, cool. So your globe paradigm states that the atmosphere is rotating dependent of Earth's rotation, which means that, hey man, if you increase the distance from the surface, you would also need to increase the velocity to maintain speed with the surface of Earth. Now, 2 things what's wrong with that, Blitz. One, that goes against fluid mechanics because you don't know what you're talking about.
It goes against fluid mechanics? How does it go against fluid mechanics?
Blitz, if I move my hand
what
back
against fluid mechanics does it go?
I'm about to show you right now, Blitz.
Please.
Blitz, if I take my hand like this, Blitz, and I move it back and forth, Blitz, is that moving the air above me and below my hand?
Sorry, can you move your hand again?
Sure. So if I take my hand like this, Blitz, or a piece of paper, and I wave it like this, Blitz,
Yep.
is the air above the paper and below the paper moving with it?
Yeah. I mean, are you familiar with the no-slip condition?
Please, you know what?
Wait, are you familiar with the no-slip condition?
No, I'm not. But
okay, so the no-slip condition is a principle in fluid mechanics that says that whenever there's a boundary, the fluid directly above that boundary moves with the boundary.
Really? So right now, Blitz, the air above my... So right now, the air in the ceiling is moving with my hand, Blitz?
I said the air right above the boundary. So in this case, the
right
boundary
on.
is between your hand and the air. So there will be like a little packet of air. You can think of it like a little packet that's moving with your hand. Yeah, that's what the no slip condition states, which is like
sure. So now,
well substantiated in fluid mechanics.
so now you're
right?
saying it is moving, but just a little bit on top, yeah?
Yeah. So what will happen is that whenever you have a parcel of air, two different parcels of air that are moving relative to each other, they will, so long as the air is viscous, which air is to a certain extent, the bottom one will drag the top one along with it, and the top one will drag the bottom, or will slow the bottom one down until you reach equilibrium.
Sure, but now the only problem with that is for you to
Can you repeat back to me what I said, please?
Sure, yeah, you're claiming that there's pockets of air right above my hand that's actually moving relative with my hand's motion, but top of
that was what I said like a minute ago. Can you repeat what I just said just now?
That's literally the main thing you just said, Blitz.
I was talking about different layers of air, but
yeah,
try
sure.
again.
You just said, like I said, there's pockets of air right above my hand that are moving, and then there's not, right?
That's not what I said. Do you want me to summarize
Blitz,
it again?
Go ahead, one more time, Blitz.
Yeah, so when you have two different packets of air that are moving relative to each other, if the air is viscous, which it is, then the viscous forces will ensure that eventually they will come to equilibrium and move together. One will slow down the other one will speed up the other, and you'll end up with eventually just one packet of air moving as a unit. Now,
really?
Yeah.
Can you demonstrate that, Blitz, or are you just saying? Are you just making claims?
I mean, if you're appealing to fluid mechanics, that's just standard fluid mechanics. That's what happens when you have viscous packets.
Give me a citation where everything moves relative to my hand moving. Can you show me that?
Can I give you a citation where everything moves relative to your hand moving? I never said that.
Obviously, I'm referencing the atmosphere above and below my hand, Blitz. You remember, you made a claim. The bottom of my hand, the air in my hand should be moving.
So the air right above your hand, right above like the surface, the top of your hand, and the air right below the surface of your hand will be moving. Yeah, that's called the no slip condition. You want a reference for that?
Yeah. So one more time, Blitz.
Okay, let me show you a reference for the no slip condition.
Blitz, if you're correct, Blitz, right? Blitz, if you're correct, let's look at this track and field one more time, right? You're claiming the track and field right next to the smallest one is moving relations to the small one, yeah?
Yep.
Awesome, right?
Yeah, so viscosity will drag each one along. The
problem with your paradigm, Blitz, is that once you increase the distance from the surface, if you're claiming that the atmosphere is still moving in relations to the surface of Earth, you would also need to double its velocity. And on top of that, where are you getting the energy from?
Why would you have to double its velocity? You would only have to double its velocity if you were like 4,000 miles up. And at 4,000 miles up, there's basically no air anyway.
4,000 miles up, there's no air. Are you out of your mind?
There's basically no air. I mean, obviously there's some particles, but I wouldn't call it air anymore.
Blitz, how high
Try
are your
breathing.
jet streams, Blitz? How high are your jet streams?
Aren't they like 30 miles up or 40 miles up or something?
Did you hear what you just said? You said anything over 4,000 miles, there's no air.
Yeah, 4,000. 40 and 4,000 are different numbers.
But Blitz, can you give me a citation for that? Anything over 4,000 up, there's no air.
Yeah, sure, I can.
Let's see that, bud.
Let me show you a chart. You'll probably accept, well, I'm just trying to find something that you'll accept. Here we go, here's a table. Let me pull it up, one sec. Open a new window. Here we go. Here we go. Sorry, this is the wrong window. This is the table I'm referring to.
Let's see, what's that? You got kilometers?
Yeah, so at 110 kilometers up, your pressure is 0.00001 kilopascals, whereas atmospheric pressure is 100,000 pascals or 100 kilopascals. So at 110 kilometers up, you are what? This is 5. You are you have 8 orders of magnitude less air. The density is 0.0000001 kilograms per cubic meter. So, yeah,
hey,
how's
do me
that?
a favor, Blitz. Do me a favor. Can you please convert that to knots for me? Because when you're flying an airplane,
To knots? Density and pressure aren't in knots.
You want me to do it for you instead? All right, you're not
Yeah, try converting pressure to knots, please. Yeah, convert pressure to knots.
So between the altitudes of the troposphere and
Sorry, convert pressure to knots, please. What's the conversion rate between pressure and knots?
Well, I'm reading. This isn't mine. This is turbulence of weather.gov.
No, I'm sorry.
So
I'm just asking for the citation that gives you the conversion rate between pressure, pascals, and knots.
Yeah, sure.
Yeah, okay, please.
Yeah, it's about miles per hour It goes between 28 miles per hour and 147 miles per hour, according to
Sorry.
this
What's the conversion rate? So you know how like it's 2.2
Yeah,
kilograms
oh, yeah,
per
yeah,
pound,
sure,
or
sure.
sorry, you know it's like 2.2 pounds per kilogram. How many knots is there? How many knots are there in
Well,
1 Pascal?
The formula says you multiply by 1.151. That's how
You multiply
so
what
take
by
that knots and you multiply
1.151?
by that.
What do you multiply by 1.151?
The knot
You multiply
approximation.
knots by 1.151 to get what?
According to this, yeah, Blitz.
To get what? To get what?
According to this, to get to knots in miles per hour, Blitz.
Right. We're not talking about miles per hour. We're talking about pascals, pressure.
Well, one more time, Blitz. I asked you, back to this reference, Blitz, if the radius is bigger from the surface.
Wait, hold on. So that's a cool pivot. Just to be clear, are you admitting that you have no idea what you're talking about? You don't know what it means to convert knots to pascals?
Yeah, I don't need a. Yeah, do me a favor. Don't gaslight me in your live.
I'm not gaslighting you. You said that you can convert
time,
knots. You said that you can convert knots to pascals, or rather, you said you could convert pascals to knots. I asked you what the conversion rate is. You said, of course you can, and no, you can't. Okay, so what? So what does that have to do with the pressure that we were talking about?
You just said anything over 4,000 miles per hour. There's no air.
I didn't say 4,000 miles per hour. I said over 4,000 miles above the surface of the Earth.
My bad. Excuse me. Correct. You said anything over 4,000 miles per hour. There's no air.
I didn't say 4,000 miles per hour. I said 4,000 miles above the surface of the Earth.
4,000 miles in altitude. You said there's literally no air.
Yeah, 4,000 miles in altitude. Yeah, okay. And I showed you a table that proves that.
You said what?
I showed you a table that proves that.
Okay, 1 second, Blitz.
Okay. Like we could do the calculation live if you wanted to. We could just compute the number density of atmospheric
Blitz,
particles
do me a quick favor.
at 4,000 miles up.
Guess. What do you think the atmospheric pressure is at 4,000 feet up, Blitz? Take a wild guess.
I didn't say 4,000 feet. I said 4,000 miles.
My bad. Sorry, 4,000 miles. My bad.
I would guess that it is. I would guess that it's like 10 to the minus 7 torr.
Okay. Here I got hyper.
Wild guess.
Well, that's fine. I didn't know it either. I'm looking it up right now, Blitz. So check it out. Here I got the altitude here. I got reference to sea level, barometric pressure.
So to be clear, I just showed you a table of this. Did you not see the table?
Well, I don't understand why you're not understanding, Blitz. Once you increase your radius, you'd have to double the speed to maintain velocity.
Wait, so to be clear, that's irrelevant to the question you asked. You asked a question about what the pressure is at 4,000 miles up. And for some reason, you asked me the same question when I've already shown you a table demonstrating that there's basically no air 4,000 miles up.
Okay, so Blitz, one more time. How many miles is 35,000 feet?
7-ish.
Okay, cool. So Blitz, one more time. If I'm going on a hot air balloon, Blitz, right? Does the ground spin underneath the hot air balloon?
You're moving with the air. I mean, it can spin underneath the hot air balloon if the air is moving relative to the ground. Yeah.
Okay, so when a hot air balloon, the ground moves
at 7 miles up, there's enough air that the viscosity can keep the air roughly moving in the same direction as the surface of the Earth. Yeah.
Okay, so with the hot air balloons, the air moves under them. I mean, the ground moves under them. Yeah.
Nope, didn't say that.
With relations to the atmosphere, so it technically doesn't.
So the hot air balloon moves with the atmosphere. If the atmosphere moves with the ground, like if it's not windy, then yeah, the hot air balloon will not, the ground will not spin underneath the hot air balloon. If on the other hand it is windy, the hot air balloon will move with the air and it'll go wherever the air is going, regardless of what the ground is doing.
Okay, so so just to give you some reference, right? The average hot air balloon flies between 500 and 3,500 feet in altitude.
Yep.
Okay, Blitz?
Sure.
Okay, so you just said that the ground spins in relations to the hot air balloon, therefore the ground...
I didn't say that.
One more time, Blitz. Does the ground spin underneath the hot air balloon?
If it's not windy, no, it doesn't.
All right, cool. This is why I'm saying welcome to Flat Earth, Blitz, because when I pull up my reference frame right here, right? Would you agree that the person in the inner field, right, the smallest radius, would you agree that the person in the smallest radius versus the outer radius, in order for them to maintain velocity, one has to double its speed?
It doesn't have to double its speed. That depends on how far away it is. No, literally not. So in your diagram, maybe the outer person would have to move twice as fast. They'd have to get out a ruler. But on the Earth, if you're 3,000 feet up, you wouldn't have to double your speed relative to the ground.
Okay, so
you'd have to be 4,000 miles up for the speed to be required to be double, because that's the radius of the Earth, right?
Well, we're referencing Coriolis, Blitz. Does it have to do with altitude or does it have to do with distance?
Coriolis has to do with latitude.
Cool. So one more time, does it have to do with?
It has to do with neither. It has to do with latitude.
Latitudes are fake lines on a ball, Mr. Blitz. So one more time. Does it have to do with
It
altitude?
has to do with latitude, neither distance nor altitude. I mean, I guess in some sense distance is related, because that will, if you're traveling further, the effect of the Coriolis effect will be able to accumulate for longer. But no, it doesn't have anything to do with distance generally.
So back to the main topic, right? So we're having an airplane here, Mr. Blitz, right? The Earth is rotating one direction, 1037 at the equator. Now, if I'm going against that rotation, would you agree that I'm also going against that atmosphere?
Yeah, that's what you feel as wind.
Awesome. So if I'm going against that altitude, shouldn't I be feeling 1,000 miles per hour wind, Blitz?
Only if you're flying 1,000 miles an hour relative to the atmosphere.
So, so I have to fly. Okay.
Incredulous laughs are not a good sign that you're winning the argument,
Blitz,
by the way.
Blitz, that's okay. You do it all the time in your lives, Blitz. Stop crying about it, right?
Oh, my laughs are never incredulous. My laughs are typically
your lives are full
derisive.
of nothing but personal incredulity, ad hominems, bro. A bunch of stupid prerogative claims just to pivot from the conversation, Blitz.
You've pivoted now 3 times, just to be clear.
I didn't pivot, Blitz. You try to pretend that if I move my hand back and forth, the air.
It's not pretending. Oh, you want? By the way, you wanted a reference for the no slip condition, right? I can just find you like a fluid dynamics textbook. Would that be helpful?
Let's see it.
Yeah. Okay. Let me go find a fluid dynamics textbook. Fluid dynamics textbook no slip. Introduction to fluid dynamics. We can actually, I'll just find a paper that shows it to you rather than a textbook, because a textbook I'll have to download illegally, you know. Yeah, so here's one. This is called The No Slip Condition of Fluid Dynamics. This is published in 1990. Let me find the paper really quick. Here's the DOI number. Here we go. All right. The title of this article, The No Slip Condition of Fluid Dynamics.
Okay, let's read it. Duffy's Papers, Constitution, Condensation, George Stokes, Service Foundation, Philosophical No Slip Condition. Okay, so that's not telling us anything that we need, Blitz. That's just telling us your
well, no, you wanted a citation that this is like a thing in fluid dynamics, so here's a citation.
Blitz, one more time. I need a citation where the air also moves with a greater radius from the center.
That's what the no slip condition is.
Yeah, that's not what that said at all, Blitz. You want to put it back up for everybody?
Do you want to just read what the no slip condition is?
Yeah, put it back up for everybody. That's not what it said at all. You're lying.
Well, so this is an article about the no slip condition. You wanted evidence that the no slip condition is real. I can give you do you want like a Wikipedia article that explains what the no slip condition is, because that might be easier for you.
Okay.
Yeah?
Yeah,
is that a yes?
I know what the no slip condition is, Blitz.
Okay. Tell me. Actually, yeah, tell me, what's the no slip condition?
Yeah, the air near the thing in motion is going to be moving relative, causing the air above it to also move.
One more time.
The air above the thing in motion, right, is going to cause the air above that to also move.
No, the no slip condition is that the air above the thing in motion moves at the same speed at the same speed as the thing in motion.
See, that's my entire thing, though. But if it's moving at the same speed, you have to generate greater velocity, yeah?
Higher up, yeah.
Exactly, that's what I'm saying.
So higher up, you have different layers, and the layers, you can use the no slip condition layer by layer if you want to go up. But the no slip condition is just about a boundary. Yeah, so at 35,000 feet, we can do this. Do you want to do the math? Why don't we both do the math and then compare our answers?
Sure, all right, bet, 1 second.
Okay, so at the equator, assuming no like unusual wind, if you will. So let's say that the atmosphere at ground level is stationary relative to the ground. Is that a fair starting point, and then we can compare answers?
Sorry, I'm gonna do it myself. Let me know what you get, bud.
Well, I just want to make sure that we're starting from the same place, okay? What is the radius of the Earth? We need that number. It's in miles. It's like 4,000 miles, right?
Well, I don't think you understand how the pressure and linear velocity changes.
3,963 miles.
Okay.
So we're at what, 35,000 feet?
Sure.
Okay, I'm just checking. It's just that because we gotta start from the same place, otherwise we won't end at the same place. Times 1,037. Right. So the answer is roughly 1,038.8 miles per hour.
Okay, wait. What? I need a difference. So I don't know why you're giving me miles per hour. I need a difference from the
It's about
surface
1.5
to
mile an hour difference.
Okay, cool. So I got, let's see here. They're sitting at 10.7 kilometers. They state that the linear velocity will need to be higher than the surface velocity.
Yeah, how much higher? Are you just reading on ChatGPT? You should show me your screen.
Can you show me your screen, Blitz?
Yeah, sure.
Sure. Yeah. I don't. You think I know how to convert this to the top of my head?
I don't think that you know how to do anything of what you're doing, which is why it's very silly that you're like trying to argue this with me.
Hey,
Here we
Blitz,
go.
one more time, Blitz.
This is the calculation I did.
I'm showing my screen, right, Blitz?
Here's the calculation I did.
Sure. Let's see
Oops.
it. And by the way, Blitz, let's see your work. Let's look at the linear relationship
Here it is.
from the surface to 35,000 feet. Let's see the difference.
There's the calculation.
3963 minus 7.
Plus 7.
That's a plus.
Yeah. It's the resolution is probably not very high.
Blitz, what the hell is
Here you
that?
go. This is how you compute the linear velocity of the wind. Yeah. How fast it would have to go to keep up. Yep.
Hey Blitz, quick question. Did you add the atmospheric pressure and also the linear relationship?
Nope, not relevant. The question was how fast does the wind have to go so that it can keep up with the ground?
Okay, Blitz, one more time. It is relevant because the point here
I'm
is
sorry,
to find
wasn't the question how fast does the air 7 miles up have to go to keep up with the ground? Wasn't that the question?
It was to find the difference, sure, in velocity.
Yeah. And so the difference in velocity is all you have to do is you have to compute the rate at which the air is moving so that it rotates once every 24 hours when it's at a radius from the center of 3,970 miles rather than 3,963.
Hey, Blitz,
you can do that fairly easily just by multiplying the linear velocity at the equator at the ground by the ratio of the distances 3,970 to 3,963.
If that's not word salad, I don't know what is, Blitz. I got a 6 kilometer difference, Blitz.
Did you use ChatGPT?
Did I not use ChatGPT? My
No, you did. So you use ChatGPT, and you're saying that my answer is wrong, but ChatGPT is right. Yeah. So this is embarrassing for you.
Blitz, you didn't even take the radius of Earth into consideration.
Yeah, I did. What do you think the 3,963 was?
3,
that's the radius of the Earth in miles. Yeah.
That's the radius of the Earth. That's not the radius of Earth.
That's the radius of the Earth in miles. Yeah.
No, it's not. No, it's not. Blitz. It's
Google
3959.
3963. That's what.
No, it's actually not. It's actually 3959, Blitz. And on top of that, 6 kilometer difference. So the main question was
3,963 is what Google says.
Blitz, how are you making up for that difference?
The 7 mile difference. Sure. That's why there's a 7 in the numerator there. That's why it's 3,963 plus 7. Blitz? What do you mean making up for it? What's the
Blitz?
It's included in the mathematics.
But if the surface velocity, right, isn't the same as the altitude's velocity, right? How are you making up for it? Because you're claiming they're moving in relations to each other.
What do you mean making up for it? Are you asking like where does it get the energy from?
Exactly, Blitz.
It gets the energy from the lower layers.
All right, show me the math for that, Blitz. Show me the math that
this is just momentum conservation.
That's momentum conservation, Blitz?
Yeah.
Really? So if it's momentum conservation, Blitz, why wouldn't we have to adjust speed from going from east to west and west to east?
How is that related to the statement that it's momentum conservation?
Let's go back to the cartoons, Blitz. Let's go back to the cartoons.
Yeah,
right,
so
ready?
Momentum conservation is why the lower layers will slow down and the upper layers will speed up until they're in equilibrium.
Blitz, you agreed that if we're going from one part of the world to the other part of the world at the equator, there would be wind that you'd have to.
There's wind in either direction, right? Because you're moving relative to the air.
One direction you're getting 1,037 mile per hour wind.
No, you're not. It just depends on how fast you're flying through the air. If you're flying on like a Cessna, like 150 miles an hour, it doesn't matter which direction you're flying in. You'll see 150 miles an hour wind.
So it doesn't matter which direction we fly.
Yeah, because you're moving relative to the Earth and relative to the atmosphere.
But it's not relative because you're going the exact opposite direction of the wind.
No, it is relative. It's just relative in either direction.
Okay. Really?
Yeah. You know,
okay, so Blitz.
So for you, it would benefit a lot from taking like an introduction to mechanics class so that you could learn relative velocities, because this is the kind of stuff that I would teach to like freshmen in college 4 weeks into a physics course.
Okay, so let's go over this, guys. So he's stating that there's no difference from east to west or west to east, even though there's a rotation in the atmospheres with that rotation at 1037.
So when you're flying west, that just means that you're rotating slightly more slowly. When you're flying east, it means that you're rotating slightly more quickly.
Okay, Blitz. So watch this, Blitz. So I'm gonna catch a contradiction that every Glover does, right? So if I'm going with Earth's rotation, right, 500 miles per hour, is the airplane moving in relations to the atmosphere?
So can you ask the question again? Sorry, I was reading the comments. If you're going with Earth's rotation, yeah.
Awesome, right? So say I'm going 500 miles per hour with the rotation.
Yeah, so you're flying west to east, sure.
Cool. So if the atmosphere is going 1037 at the equator, yeah?
Mm-hmm. Relative to the center of the Earth, sure.
And if I'm going only 500 miles per hour, Blitz?
Relative to what?
How do I 500 miles per hour relative to Earth's rotation?
Earth's rotation is not a reference point. So is it relative to the center of the Earth?
500 miles
is it relative to the
Blitz,
center of the Earth or relative to the surface of the Earth?
Obviously, the center and surface, actually both.
Well, the center on the globe model, the center and surface are moving relative to one another, so it can't be both.
Okay. So, okay, Blitz, one more time, man. Look, if we're going, the ball's turning. Your
incredulous laugh is very funny.
Yeah, it's fine. Blitz, look, your donut's going this way, right, Blitz?
Your donut? What donut?
All I'm asking, Blitz, is if I want to go from, let's use my hometown, for example, right? Mm-hmm. I live in Florida, Blitz.
Okay? That we grant that.
Cool. So if I'm in Florida, Blitz, and I'm going to California, Blitz, right, would you agree that that's relative to the equator? Or do you want me to go closer to the equator?
You can. It can be from anywhere to anywhere. It doesn't matter to me.
It's just as a reference argument, yeah.
That's fine. That's fine. So you're flying from from Florida to California. Sure, you're flying east to west.
Awesome. Cool. So if I'm going here, hypothetically, I don't know the exact hours. Let's say it takes 10 hours. Yeah, Blitz?
It's like 5, but sure.
Florida to California is not a 5-hour flight, Blitz.
Yeah, maybe 6.
I'm pretty sure.
I've done the flight. Like but anyway, go ahead.
Whatever. Yeah. Say it's 5 or 6. Who cares? Yeah. Mm-hmm. So if we're going one direction with the Earth's atmosphere that's rotating.
That would be against the Earth's atmosphere. That'd be against the rotation.
So if it's against the rotation, is the velocity the same?
Velocity relative to what?
Earth's atmosphere.
So, yeah, relative to Earth's atmosphere, yeah, your velocity, you'll go, I don't know how fast modern airplanes go, like 800 miles an hour relative to the Earth's atmosphere west, or 800 miles an hour relative to the Earth's atmosphere east?
500 miles per hour, Blitz.
Are they? Oh no, sorry, it's like 800 kilometers per hour. You're right. So let's say, it's 500 miles per hour west relative to the Earth's atmosphere, or 500 miles per hour east relative to the Earth's atmosphere. In either case, it's the same speed relative to the Earth's atmosphere.
Okay, cool. So now, guys, are we all heard? All right, you know what? We're gonna go with Blitz argument. Cool. So Blitz, in your narrative, you will go the same speed, yeah?
The same speed relative to the Earth's atmosphere, right?
Sure.
If it's windy, for example, if it's windy, then you might travel at a different speed relative to the ground. Right? If the wind is blowing at a different speed relative to the ground because, maybe there's like a storm or something, then it can matter. But I mean, generally, if there's no wind, then 500 miles per hour relative to the Earth's atmosphere will also be 500 miles per hour relative to the ground.
Okay, so cool. So now we're getting two different answers. So now wind's going to change this, but at the same time, wind doesn't change it.
Hold on. To be clear, of course wind changes it.
Okay, so if wind changes it, Blitz, then why are we pretending that it's the same speed it takes to go back and forth both directions if it is dependent on wind?
If it's windy, then it won't be the same amount of time to go between the two.
See, that's what's wrong with you.
If it's not windy, then it will be.
Okay, so now you're gonna go back on what you're saying. Now it's all dependent on the wind. Yeah?
Wait, to be clear, this has never been a point in contention. Do you think that like if it's windy, even on a flat Earth, if it's windy, the amount of time it'll take to go from point A to point B will be different, right?
Sure.
So of course wind is going to affect it. Because wind affects how the air moves relative to the ground, and if the air is moving relative to the ground in the opposite direction of the way that you would like to go, you'll go slower relative to the ground. That has absolutely nothing to do with the shape of the Earth. It applies equally well on both of our models, which you don't have a model, but
that's fine. So now you're admitting that wind changes the speed and duration time, yeah?
What do you mean admitting? This is obviously true. Everybody agrees on this.
One second. Now, if that's true, that wind can change the yeah.
Yeah.
Then how does wind not change when you're fighting against this sheer wind? So when you're going the exact opposite of Earth's atmosphere, yeah, you're fighting that sheer wind.
You're pointing in the wrong direction. When you're going from west to east, you're going with the atmosphere.
So one more time, Blitz. Yeah, you're right. So Blitz, one more time. If I'm going the exact opposite of Earth's atmosphere, yeah, do you agree that there should be wind shear?
No, because look,
so there's
when
no
we talk about wind, we're talking about motion of the air relative to the ground, right?
Yeah, 1 second.
That's what we mean by wind.
Okay, hold on 1 second.
Can you answer the question? Can you answer the question, please?
It wasn't a question. That was a statement.
No. It was definitely a question. There was a question mark at the end. I said, do we agree that what we mean by wind is motion of the air relative to the ground?
Sure.
Okay. So if the air, on average, in the absence of wind, the air is moving with the rotation of the Earth, then again, if there's no wind, there will be no wind shear that changes the rate at which you're flying through the air, the travel time through the air from LA to Miami or vice versa, because the air is moving with the ground. There's no wind. So you'll either move you'll either end up going slightly faster than the rotation of the Earth or slightly slower than the rotation of the Earth, depending on which direction you're going in.
Yeah, 1 second, Blitz. I agree with that though. Yeah, it's really.
Are you typing to ChatGPT again?
Yeah, Blitz. I don't know how to convert this into.
So to be clear, I thought I was debating you, not the internet, not ChatGPT.
This isn't the internet, Blitz. You're debating me. I'm using the internet to convert my math. I'm not a mathematician like you, right, Blitz? So give me 5 seconds, bud.
Didn't you?
Unless you want to
just to be clear, weren't you like quizzing people on mathematics yesterday?
So first of all, I was quizzing somebody on 3rd grade math because they had a bunch of fucking ad homs towards me that they didn't even understand themselves, right?
What was the 3rd grade math that you were quizzing people on?
A derivative. I asked them what was, I think it was the derivative of 8, I think.
Yeah, and what's the answer to that?
0.
Yeah, and what did Ian say?
I don't know. I think
he said 0. Ian said 0. Yeah.
Okay, well I don't know.
And you said he was wrong.
Typical. All right, so check it out, Blitz. I'm gonna show you the math. Even if you can just review this real quick in 5 seconds, you can do it top of the head, right?
Yeah, so I wouldn't use ChatGPT to do math. Ask it to multiply.
I'm using it, Blitz. You just gotta look over the math.
No, you shouldn't. Ask it to multiply 2 5-digit numbers together, and it'll get the number wrong.
2 5-digit numbers?
Yeah.
Really? All right, I'll do that right after this. If you're right, Blitz, then
at least that was true in ChatGPT 4. I don't actually know about ChatGPT 5 now.
Would you like me to use Grok? You want me to use a different?
No, you should just use a calculator.
Okay, cool. Well, I'm gonna know that on top of my head, Blitz. So let's do it real quick.
You don't know what? You don't know how to use a calculator on the top of your head?
Oh my gosh, Blitz! Look at this. There's a difference of 2.8 hours. Holy fuck! Wow.
I don't know. So can you explain the calculation so that I can see what's going on?
Sure. They took the distance between 2 cities and airplane speed going average 900 kilometers per hour. They took the average jet stream. Oh my god! Somebody's calling us. My bad. Sorry about that. Dude, Blitz, dude, if only you had a brain, man. All right, ready, Blitz?
Yep, go ahead. So what were you saying about the jet stream?
Okay, here we go. I'm gonna show you the math. So the misconceptions here.
Sorry, you were reading something. So go ahead. You said something about the jet stream.
All right, let's assume. So the case here we go. Let's start here. So they took an airplane.
Why not start from the beginning? Actually, let me just make you big.
Sure.
I think does this work? Okay, cool. This works. Yeah. So we're flying from London to New York. We have an airplane speed relative to the air of 900 kilometers per hour. Jet stream wind speed 900 kilometers per hour. So the wind speed we're assuming is 150 kilometers per hour. So we're assuming that there's wind, right?
It's a constant though. They took the constant at that altitude.
Well, so there is something called the jet stream, which is a type of wind that's like almost always blowing at a certain altitude at certain latitudes. And so, yeah, if you include wind that's always blowing in a particular direction relative to the ground, then of course you're going to get different answers. That's what I said. What I said is that if you have wind that is going in the direction you'd like to go, it'll speed you up. And so, of course, if you have wind that's blowing from New York to London, it will speed you up. You'll get there faster. The question is what happens if there's no wind?
Wait. Blitz. I'm taking the average here, Blitz. I'm taking the average jet stream with the speed in kilometers.
Yeah, so do you know what the jet stream is? The jet stream is a type of wind.
Okay, that's fine, but why are you crying about the constant?
I'm not. That's just a normal
Okay, cool. Then, okay, then I
like
don't know why
wind
you
speed.
even saying that. That's just fact.
The point is that
That's the average.
if you include wind that's blowing in a particular direction, of course it's going to affect the speed that you get to your destinations. We've already agreed on
Okay,
that.
so when I asked you, Blitz, so when I asked you if I'm going from east to west or west to east, would do get there in different times? You said
Only
no, but now
I said no if there's
now
no
you're conceding
wind.
to the wind.
I said no.
Now
I'm
you're
conceding. I
conceding
said no if there's no wind.
All right, well, Blitz, by the way,
Should we
there's a
replay this?
3.81
Should we
hour
replay
difference.
the audio so then everybody can hear me say no if there's no wind?
Okay,
Should we
but look at
replay the audio?
That's
Should we
fine, but
replay
can
the
you
audio?
also
We
look
should?
at the-
Okay, hold on. Let's replay the audio.
Look at the final answer, though. Look at the final answer, Blitz.
Hold on. We're going to replay the audio really quick.
Blitz, if you know there's wind and jet stream, why the fuck would you say there's no time difference, Blitz? Blitz, can you
I
answer that
said
for me?
if
you
there's
know
no
there's
wind, then the times will be the same. And then I said
But
if there's wind,
that's so
if there
stupid,
is
Blitz.
wind, the times will be different. But the
Oh
wind
my
is
God,
not
you
from
are
the
such a
rotation of the
sneaky
Earth.
Snake. You're a slippery little snake, Blitz.
Hold on.
Blitz,
I got to mute you so then we can listen. I think we're. Here we go.
I agree with that. Wait, Blitz, hold on, buddy.
Wait, hold on. So you heard that,
Go
right?
ahead. I already know you said that, bud.
Okay, so if
Blitz,
there's no
one more-
wind, then the speeds will be the same. If there is wind, then the speeds will be different.
Blitz, you said there's no fucking wind at 4,000 miles, Blitz.
Wait, hold on. No, I didn't. I said there's like
Yes,
no
you
air.
did.
I said there's no air.
So there's wind, but there's no air. How do you have wind without
Hold
air,
on.
Blitz?
To be clear, at 4,000 miles up, I don't actually know if there's any wind, but planes don't fly 4,000 miles up, so it's not really relevant.
Yeah, why did you show me that graph? You just showed me a wind chart.
Because we were
based on
talking about
altitude.
something else. Why'd you bring up the
Oh
4,000
my
miles
God,
thing?
Blitz,
We were talking
you're
about something else at the
fucking
time.
Snake, Blitz. You are a fucking lousy snake. It's okay, though. I don't care. Let's keep moving on, Blitz.
Yeah, let's keep moving on. Okay, so you brought up your piece of evidence, which is like obviously bunk. Now, what do you make of the what do you make of what do you make of the neutrino experiment called Minos?
Yeah, 1 second. Oh, nice fucking pivot, Blitz. Holy
We're
fuck.
so you
Nice
brought up your
pivot.
evidence. Now I'm bringing up my
Wow.
evidence.
1 second. You didn't even look at the final answer, Blitz. We didn't even pass the fucking wind shear. 1 second, Blitz.
Wait, so where's
just
the
want-
1,000 mile an hour wind shear?
You said what, buddy?
What I thought that there was supposed to be 1,000 miles an hour of wind shear.
Well, you're
Why
also
didn't
going
ChatGPT
500.
Why didn't ChatGPT include that?
She does. Watch this.
Oh,
Blitz.
where? Where's the
Well,
1,000
first
mile an
all-
hour
first
of wind
all,
shear?
You said it was a constant, Blitz.
What I said? What is a
Right.
constant?
So let me show you the final
What did I
answer,
say
and
is a
you can
constant?
tell me-
What did I say is a constant?
You
Don't
said
put words in
there
my
wouldn't
mouth.
be 1,000 miles per hour wind shear because it's relative to Earth's atmosphere. It's moving with Earth, the atmosphere.
Well, yeah. And so where did
what
they
you said,
include
Blitz.
this 1,000 miles an hour of wind shear?
Whoa, this is going with the wind.
So if it was 1,000 miles an hour, you should add that or subtract that from the speed, right?
Well, it's got it right here. Ground speed 1050 right here, the atmosphere. Right.
To
So
be clear,
would you
that's
say-
1050 kilometers per hour, and they got that by taking the
Sure.
900 and adding 150 to it. That's not the rotation of the Earth.
Hey, Blitz, one more look at the top. This is the math you want to look at right here, buddy.
Yep.
Right? They
Take
the
900 and
velocity,
add.
the
Take
velocity
yeah. So you can add it, and you get 1050. 110 or
Okay.
1,050 kilometers per hour, and then you can subtract it,
Sure.
and that's exactly what you would do if you had 150 kilometer
Cool.
winds. Now, where's the 1,069 kilometer? Where's the 1,060 mile per hour winds included in this calculation?
right.
So it's not there.
Okay, what?
So you're
One
so you're
second,
wrong.
Blitz.
I'm sorry, you're wrong. You thought that you thought that you should somehow include the rotation rate of the Earth, but you were wrong about that.
Okay, 1 second. Okay, here you go. Okay, but I'm gonna show you both. Okay, here, the figure quote is sometimes described as equatorial winds. The answer is no, there's not an actual wind blowing a 10 at the equator. Okay, it's just 24-hour circumference. Cool.
Oh, so it
velocity.
agrees. There's not actually 1,037 mile per hour wind at the equator.
So it says if you're standing at the equator, you're moving eastward at 1037 relative to Earth's axis. You don't feel it. Okay, who cares, right? So
okay, so ChatGPT agrees with me. I'm glad we agree.
That's fine, but look at the time difference here, Blitz, right?
The time difference is because of the wind. It's because of the jet streams. It's not because of the rotation of the Earth. It's not because you're moving with the Earth's rotation or against the Earth's rotation.
Blitz, where do you get the wind, Blitz? Where do you get that wind if it's not due to the Earth's rotation? Please explain that.
So the cause of the various jet streams and what are they called? There's another word for this. There's jet streams, there's trade winds, there's a whole bunch of kind of like canonical winds that blow on the surface, that blow like on. It's not word salad. There's a whole bunch of different like typical winds that blow on like the near or on and around the surface of the Earth. And the reason why they're there is pretty complicated. There are things called like pressure cells and different temperature differentials that arise because the poles are colder than the equator. The actual dynamics giving rise. So the rotation of the Earth does play a role, but the dynamics are a lot more complicated than that.
Okay, cool. So it does play a role, but complicated.
Yeah, so for example, the trade winds go in the other direction, if I remember correctly. Let me double check. Right, so there are westerlies, which blow from west to east, and these are north and south of 30 degrees. And then there's the trade winds, which blow from east to west.
But brother, we knew this. That's why when we started this conversation, I asked you, hey buddy, if I fly from two opposite directions of Earth's rotation, would there be a time difference? Obviously, we're fucking including the air.
If you're including standard wind, then we could do the calculation. But if you're flying from north
that's standard wind.
So to be clear, if you wanted to include the average wind speed, we could. But if you're saying that assume that there's no wind because wind obviously complicates it, then they're going to move at the same speed. Obviously it's the same. Now, if you want to include like the jet streams and the westerlies and the trade winds and all of this stuff, we can, but then we'll have to know what latitude you're at, we'll have to know what altitude you're at, and so on and so forth.
Okay, so do you understand? Okay, so you understand the main dilemma here is that there's almost a 3-hour difference. That's going from east to west.
So if the wind was as you suggested it should be, that it should be blowing at the speed at which the Earth is rotating, then you wouldn't even be able to travel on an airplane from, say, I don't know, like Jakarta to Ecuador, right? You wouldn't even, Ecuador to Jakarta. You wouldn't even be able to do that because the planes can only go 800 or 500 miles an hour, whereas the Earth rotates at 1,000 miles an hour. But you can do that. You can travel. You can travel that speed. You can go those distances.
Blitz, look at this, buddy. All right.
Giggles.
So 1 second, Blitz. Look, you said at first that there's no wind at 4,000 feet up.
I said 4,000 miles, and by the way, I never said there was no wind at 4,000 miles. I never said there was no wind at 4,000 miles. I said that there's basically no air at 4,000 miles.
You can get that. You're right. You did say that in miles, not feet. Awesome. And on top of that, Blitz, do you see where it's kind of you being disingenuous, pretending like
you've been putting words in my mouth this whole time, and you're accusing me of being disingenuous? Are you serious?
Yeah, Blitz. Why the hell would I not include wind when I asked you that question, Blitz? Oh, okay.
To be clear, you didn't say, oh, and yeah, include wind. And so when I specified my answer, I said if there's no wind, then they would be the same. If there is wind, then they wouldn't.
Okay, but okay, you know what's weird? This is telling me there's almost a 3-hour difference, east to west, west to east. But Blitz, how come whenever I pull up any flight chart going from California to Florida, their fucking return flight is the same as their fucking takeoff flight? Why is the speeds the same? It takes the same amount of time to get from Florida to California and California to Florida.
I actually don't think that's true. I used to fly. I used to fly a lot. I mean, we can check this. Flight from Los Angeles to Miami. So I just found a 5-hour let's take the fastest one. So Delta is 4 hours and 50 minutes from Los Angeles to FLL. And then let's look in the opposite direction. Delta is 5 hours and 27 minutes. So it's like 30 minutes faster to go from Los Angeles to Florida than the other way around.
Well, but according to your Earth's rotation and your Coriolis donut effect,
this Coriolis has nothing to do with this. No, there shouldn't be a 3-hour difference. No.
So the math that we just did, you don't agree with?
Well, so the math that you did was from London to New York and vice versa.
Cool,
Los Angeles to... Okay, yeah, we can look up London to New York if you want. I think London to New York is a 6-hour flight, by the way. So I don't actually know why it assumed it was 10 hours, but That's fine.
Okay.
So London to New York is
8 hours nonstop both ways, but
it's 7 hour 50 minutes on British
thanks
Airways,
for playing, Blitz. Thanks
and
for playing, Blitz.
in the other direction it's 7 hour. Why are you lying?
I just showed you it's the exact same speed there and back. It's
Wait,
8
no, hold
hours.
on, bro. Why are you lying so much? I can pull it up.
Wow,
I have the
what?
numbers right here.
Okay,
So this
watch
is
this,
London
Blitz.
to New York. We have an 8 hour 10 minutes, 7 hour 55 minutes. We have 8 hour 10 minutes, 7 hour 50. So about 8 hours from London to New York. And then from New York to London, we have 7 hour 10 minutes, 7 hours, 7 hour 20 minutes. It's like an hour shorter to go from New York to London.
Blitz, if it's an hour shorter, why when we took the average of the wind speed, why was it
Probably because the calculation that ChatGPT did was wrong, because it relied on like some inaccurate measurement of the jet stream or some inaccurate measurement of plane speeds. This is why you don't rely on ChatGPT.
Yeah, sure, says the guy that says there's no wind. All right.
I never said that there was no wind.
Okay. So Blitz. All right. If you don't mind, bro, I'm gonna move on to my next topic.
No. So you got to bring up something. I get to bring up something. That's how this is gonna go.
Oh, go ahead, bud. Go ahead.
All right. So have you heard about the Minos experiment?
With neutrinos, yeah, I heard about your neutrino bullshit, dude.
Okay. So they point the neutrino beam down into the ground, 3 degrees. They send it 700 kilometers away, and then it hits a detector slightly underground, like a little bit underground. And it hits the detector coming up from the ground, like it's angled upward. How do you figure that makes sense on a flat Earth?
That's actually a good question. I can concede and say I don't know.
Okay. I mean, it makes a whole lot of sense on a globe Earth. It doesn't make any sense on a flat Earth.
That's correct. I did look into neutrinos. Let me ask you this: can neutrinos become polarized?
Can neutrinos become polarized? Yeah, neutrinos have polarization. Sure.
So how do they have polarization without an electron?
They don't need to have an electron to be polarized.
All right, cool. So if they're polarizable, right, that means
polarization has to do with spin.
So can I ask you a question?
Sure.
If they can become polarized, can they be affected by Earth's electric field?
I don't think neutrinos have a magnetic moment. No, they're not polarized magnetically. They're polarized in like a particle physics sense.
So they're polarized.
So we can talk about like the they're just words that are used in different senses in different fields, right? So they have 3 degrees of freedom. So you can have spin that's in one of 3 possible directions, right? It's basically what the polarization of a massive particle is. It's the direction that its spin is pointing in.
Yeah, I mean, one more time, Blitz. I never studied or even questioned on neutrino. I've heard about the argument, but I've never actually looked into it. So I don't know what you expect me to say to that.
I expect you to say that it doesn't make sense on a flat Earth.
I already said that.
Okay, that's fair. All right, you want to break your next thing?
Yeah, sure. Let's go over the airplane thing one more time, but not Coriolis. Now we're going to debunk everything.
Wait, hold on. We didn't talk about Coriolis at all, just to be clear. We weren't talking about Coriolis at all.
The wind shear, wind fronts, but sure, we didn't talk about Coriolis.
Yeah, that doesn't have anything to do. Well, okay, so wind shear actually, in some sense, does have to do with Coriolis because it has to do with the cells that are rotating, basically. But but the rate at which the Earth spins and the rate at which the wind, like the atmosphere moves with the Earth, that doesn't have anything to do with Coriolis. Anyway, go ahead.
Okay, cool. So Blitz, real quick, when you're flying an airplane, Blitz, do you have to drop your nose circumference curvature?
I mean, sort of in principle, but in some sense, it's kind of done automatically.
So I need a yes or no answer, Blitz. I can't like your word salad shit you do.
Saying sort of in principle, but it's kind of done automatically isn't word salad. It's an explanation.
Kind of, sort of.
So for example, if you pointed your nose at a distant star, and then you pointed your nose there, as you traveled, that star would appear to rise higher and higher, and higher and higher relative to the horizon. So if you wanted to keep relative to the horizon, you'd have to then angle down relative to that star.
Okay. So,
but because of the way that planes work, based off of, in particular, where their center of lift is as opposed to their center of mass, you get an automatic torque.
Cool. So Blitz, do you have a geometric horizon? That's the distance and location we can find mathematically.
So the apparent location of the horizon depends on atmospheric effects. I'm sure you know this. Wait, hold on. Why are we changing the topic again? Are we not talking about the plane thing?
We are. It's relations to your attitude indicator.
Oh, okay. Yeah. Okay. Sure. Fine. So there is a like a I don't want to say technical, like a virtual horizon, I guess, that like a plane will use, and that's just perpendicular to down, right? And then there's like the actual what direction you have to look in to see the horizon, and that won't necessarily be in the same direction. Sorry, artificial horizon, that's what it's called, not virtual horizon. Then there's the actual direction that your eyes have to point in order to see the actual horizon, like, you know, out there in the real world, and those will not be aligned with each other, right? The artificial horizon will be higher than the actual horizon.
All right.
You have to look down a little bit to see the horizon.
Okay, so that, I mean, I would assume so, right? If you live in a ball, you should have to look down,
Yep.
right? I would assume so. Yeah. So the only problem is that you don't, and that the horizon.
Where's the evidence of that? Can you? Where's the evidence of that? Show me the paper.
I got you. We're coming up on. It's loading. I don't know what the hell is taking so long to load.
I swear to God, if we're using ChatGPT again, I'm gonna laugh so hard.
It's not, bro. No, it's not ChatGPT.
Okay.
So real quick, can we both agree that if your radius is 3959, right, Blitz, that you should have to have a drop rate of 69.1 miles per degree?
Drop rate of 69 miles per 1 degree? No. No, every 69 miles you travel, you have to change your angle by 1 degree. Yeah.
Exactly, right. So there's a degree change.
Yeah.
Awesome. So in 720
Wait, hold
seconds,
on.
Blitz,
So why are we using? So this is this DeepSeek?
1 second, Blitz. No, this isn't DeepSeek. This is just off the dome, Blitz.
Can you show me the top of your browser?
Yeah, this isn't DeepSeek, man. This is bounce.com, bounce.net.
Okay.
But so Blitz, look, every 720 seconds, that's about 12 minutes. You have to count for about 1.2 degrees.
You have to.
Blitz.
Well, yeah, sure.
Cool. So that means in a
1 degree.
1 hour flight going 500 miles per hour, that's about 7.2 degrees of change you would have to count for, right, Blitz?
Sure.
Awesome. Right on. Now let's go over here.
Oh wait, actually, hold on. To be clear, you don't necessarily have to account for it as like a pilot flying manually, right?
It doesn't matter.
But relative to a fixed star, your angle would change by like 7 degrees. Yeah, sure.
Sure. Right on. So we're gonna compare what you just said, and you just admitted and attested you would have to account for that, and it would change. Awesome.
No, I didn't say that you would have to account for it. I said that that's what would, like, if you were relative to a fixed star, your angle does change.
I'm not saying it. Whether it's a pilot, the airplane itself by itself, who cares? The airplane itself.
By like passive element, yeah.
Okay, perfect. What I like to hear, Blitz. Okay. All right. Here's your change and drop from your radius, right, and your degrees change per distance, feet and miles, inches, and seconds. All right. So now, when you magnify this change, Blitz, can you agree that an average airliner flies about 2 degrees positive pitch?
I have no idea. I mean, if you tell me that they fly 2 degrees positive pitch, I'm inclined to believe you. I probably shouldn't be, but I'm inclined to believe you.
I mean, yeah, you probably shouldn't, so you should probably look that up yourself, Blitz.
Okay. Average pitch relative to artificial horizon for commercial airline.
I don't know why this isn't loading.
So apparently it varies significantly depending on the phase of flight. During cruise, so this is weird because I'm getting different answers depending on where I'm looking. Okay, so Reddit says a typical cruise pitch for an A320 is 2.5 degrees nose up with thrust at about 84 degrees or 84%. Sure.
Okay, cool. So are we agreeing with this, or are we not agreeing with what I just
With the 2 degrees, that's fine.
All right, cool, right on. Well, I was referencing just an average commercial airliner, but...
Yeah, sure, that's fine.
All right, 1 second, bud. Okay, cool. So Blitz, I have a pitch graph here that's going to go over with what I'm about to claim, what positive claim is, right? So 1 sec. So this is a pitch graph, yeah? Okay, so real quick, here's the word pitch. It changes during takeoff and then landing, and actually stays relatively consistent.
Sure.
So this is about a 2 hour. This is about a 2 hour derivation right here between the
2 hour flight. You mean a 2 hour flight?
Well, it's more than 2 hours. It's almost 2 hours and 50 minutes.
Yeah. So that's pitch relative. That's pitch relative to the virtual horizon or the artificial horizon, right?
Sure.
Yeah.
Exactly.
Okay.
Yeah. So relative to that, it's a positive pitch for 2 hours, Blitz.
All
right. Awesome. So now, if that's positive for 2 hours, Blitz, then my contestation is this right here, bud. All right.
Oh, you forget that it's positive with respect to the artificial horizon, not positive with respect to the original orientation. The artificial horizon changes as you go around the Earth.
What do you mean by changes?
The artificial horizon is the tangent, well, at least in principle, it's the tangent, or rather it's the Earth, it's perpendicular to the straight down that you get from gravity, right? Well, it doesn't have to be from gravity, but it's straight down. So the point is as you go around the curve of the Earth, if say you were doing 100% level flight, right? If you're doing 100% level flight, which I guess commercial airlines can't do that, but suppose that they could. Suppose that they could fly at a pitch angle of 0 relative to the virtual or to the artificial horizon. Well, as they go around the Earth, they will still stay at 0 degrees because the artificial horizon is always staying perpendicular to this, or is always staying perpendicular to the downward direction. So you would expect that the pitch would never change relative to the artificial horizon. That's exactly what you would expect on the globe, because the artificial horizon follows the essentially the curve.
All right, do you hear what you just said, Blitz? It follows the curve.
Well, it essentially does. It follows I think it follows gravitational gradient. I could double check actually what the artificial horizon uses. I imagine it probably uses. No, I imagine it probably uses gyroscopes and then probably some gravitational corrections, but I can check.
So, okay, don't get nervous on me.
How does the artificial horizon orient itself in a plane? I actually don't know the details here.
Okay, go ahead, do your research. Go ahead.
Okay, yeah. So it uses so at least in older aircraft, it used gyroscopes and pendulous vanes to keep the vertical of the gyroscope pointing up relative to the ground, or relative to gravity, you might say.
Sure,
and so
it's a reference pitch was 0.
Yeah. And so you're always relative to that. So if you're going around the Earth, the gravitational direction will change, which will mean that the gyroscope direction will change, which will mean that your pitch relative to the artificial horizon will not change.
Really?
Yes.
What about your gyroscope? Would that change?
What do you mean? Where about your gyro? I don't even understand what that sentence meant.
So
Can you say it again?
Attitude indicate. You said the pitch will stay constant, yeah.
Well, assuming you're staying in level flight, yeah.
Cool.
I mean, like if there's like turbulence and stuff, I'm sure it'll change.
Okay, so if your pitch is staying constant, right, would your gyroscope show the difference?
That's what the pendulous vanes were for, because they keep your gyroscope pointing, following the curvature of the Earth. Otherwise, you wouldn't need pendulous vanes in the first place. And I guess pendulous vanes are like old tech. Now we have better tech, but they used to need pendulous vanes. Why would you need them if the Earth was flat?
Okay, so that's the entire point. One second.
Wait, can you answer that question? Why would you need pendulous vanes if the Earth was flat?
Because first of all, they're in reference to the takeoff. They're in reference to a 0 inertial frame.
Do you know what pendulous vanes are?
Yeah, it's in a gyroscope.
What do they do?
They count for any change in angles.
So if the Earth was flat, why would the angle change?
Well, that's the entire point. It doesn't change. That's why I have the pitch.
Then wait, why do you need pendulous vanes then if the angle doesn't change on a flat Earth?
Because whenever you're flying in the clouds in the dark time, Blitz, you can't see the horizon, which is what you're.
But the gyroscope would just stay oriented up the whole time. It would never need to be adjusted if the Earth was flat.
That's a good question. Why do they have that if we're flying over a flat plane? That's a good question, Blitz.
Because we're not flying over a flat plane.
Well, you say that, but I'm about to show you that we.
If you can't give an explanation as to why there's pendulous vanes on old aircraft, then I think that you've lost on this point too.
Well, it's not about losing. It's about which one has evidence, right?
Yeah. So I just gave you a piece of evidence. Pendulous vanes existed on old aircraft. Now they use like more modern stuff, but they existed on old aircraft. And if the Earth was flat, they wouldn't have existed on old aircraft.
Okay, so Blitz, just because I say I don't know why they have one on there doesn't mean I'm wrong, right?
Well, it kind of does. Do you have it? Like, if you can't offer an explanation to why this is the case, and I can, and my explanation actually works, it actually makes sense, and is consistent with all of the data. Yeah, it does.
So
it seems like all of the evidence against the flat Earth and for the globe, you're just like, yeah, I don't know why that's the case. Maybe it's because the Earth is a globe.
No, I think it's because falsification is independent of replacement. You're trying to strong arm me, bro, real quick.
Falsification is I just falsified the flat Earth.
You didn't falsify the flat Earth.
The existence of pendulous vanes falsifies the flat Earth. Yeah.
You said
it absolutely does. If the Earth was flat, pendulous vanes would not exist. Pendulous vanes do exist, therefore the Earth is not flat.
Okay, well, they do exist, and let's go over the drop rate, the degrees that they don't account for, right? So you admitted you'd have to account for this in your gyroscope.
You admitted that pendulous vanes exist, and therefore the Earth isn't flat.
What the hell?
If we're putting words in each other's mouths, that's what we're doing.
This is a shitty strongman right there.
I mean, you've been doing that the whole time. You just admitted, like,
Why isn't this shit loading, bro? Oh my god.
Great question.
I've loaded this shit like 20 times. What the hell? Dude, that's actually weird. I guess it's not working, so I guess I'm fucked right now, man. But as far as that presentation goes, so we go back to this if you want, though. But so long story short, Blitz, on a 2-hour flight, there should be about 14.7 degrees of change from that.
Yeah, sure. 14.7 degrees of change relative to the initial orientation of the gyroscopes. Yeah.
Sure, right on. So
but the gyroscope orientation changes over time, and at least in old aircraft, they use pendulous vanes to do that.
All right, see, now
that's what the pendulous vanes are for. The pendulous vanes were for changing the orientation of the gyroscope so that it would stay vertical with respect to the ground.
So Blitz, if your test status would change, why the hell doesn't it change on the pitch on the
pitch? The pitch that's measured there is relative to the artificial horizon, and the artificial horizon is determined by the gyroscopes. And if the gyroscopes are changing at exactly the rate that would be required in order to follow the surface of the Earth, which they do, then you would expect to see zero pitch change because that's relative to the artificial horizon.
Okay, so would you admit that if you're going from the North Pole to the South Pole, since you don't have to account for curvature with your nose, right? Would you admit that the gyroscope would be up to that?
Why wouldn't you have to account for curvature with your nose going from north to south?
Well, that's what you just said. What the hell are you talking about?
I mean, like, so.
Oh my God!
Hold on, just to be clear, are you making a distinction between east and west and north and south?
Oh my gosh, dude, what the hell are you?
Like in both cases, the pendulous vanes, at least on old aircraft, are going to adjust the orientation of the gyroscope so that it changes direction as you fly over the surface of the Earth.
Okay.
Right.
Sure.
Whether north, south, or east or west.
So if it changes from the North to South Pole, would it change in a 2-hour flight?
From North to South Pole? You can't fly from the North Pole to the South Pole in 2 hours.
Any 2-hour flight, doesn't matter where.
Yeah,
would it change in a 2-hour flight?
You mean the orientation of the gyroscope? Would that change? Yeah, of course. Assuming that you're not flying in a circle, I guess.
Walking on flat Earth, because it doesn't change. It's all flat right here.
Wait, do you have a measurement of the gyroscope position relative to the fixed stars? Because the pitch is measured relative to the gyroscope. It's not measured relative to the fixed stars.
So you're telling me the pitch can stay constant and the gyroscope change?
Yeah, if the pitch and the gyroscope are changing at the same rate, then the pitch relative to the gyroscope will stay the same.
All right, well, let's go there real quick.
Mm-hmm. Wait, do you actually not understand what I said, or are you just being incredulous on purpose?
No, I think you're actually speaking of things you don't know, and you're about to get cooked on it. So
no,
check it out.
This is something I know about.
The precision of a gyroscope would be dependent on the pitch. Wow, holy fuck.
Wait, hold on. So did you account for the pendulous vanes that adjust the orientation of the gyroscope?
Wait a minute. You just said the pitch can change. Blitz, you just said that the gyroscope can change without the pitch changing.
No, I said that the gyroscope. Then you just didn't understand me. The gyroscope changes. I will re-explain. Open up your listening ears. The gyroscope's orientation changes as a result of the pendulous vanes. Now it changes at a rate that tracks the surface of the Earth, because the surface of the Earth, the pendulous vanes make it so that the gyroscope points orthogonal to the surface of the Earth. Now, please, I'm in the middle of an explanation. Now, the pitch can, if the pitch also follows the curvature of the Earth, then relative to the gyroscopic orientation, the pitch will also never change, because they're changing at the same rate, right? Go ahead.
All right, so now you're saying that they're changing at the same rate. So now you're admitting that, hey, that if the gyroscope changes, so would the pitch, yeah?
No, look, so when we talk about changes, we need to talk about relative to what, right? Because if two things are changing together, then from the perspective of one, the other one won't look like it's changing at all. Do we agree on that?
No, I don't agree with anything you're saying. That's none at all.
Okay, question. Let's say that you're sitting in a train. Train is moving. Sure. Is your position changing?
Is my position changing?
Yeah.
Well, that's totally not analogous. We're talking about...
Just answer the question. Just answer the question.
That's not analogous at all.
Stop running. Just answer the question.
How the fuck am I running, Blitz?
Because you won't answer the question. A very simple question.
Brother, you're asking about a train.
Yep, because trains are easier to understand.
About
answer the question, Free.
Nodes of a plane to the horizon.
Free, answer the question.
I mean, obviously on a fucking train, no.
The train is moving. You're sitting on the train.
Sure.
Is your position changing?
I just said no.
So, If somebody looks at you while you're sitting on the train, you won't be moving at all?
If they look at me and
Yeah.
what in relation, independent of the train moving, no.
Sorry, I
I'm
didn't say
moving-
independent of the train moving.
That's my point. I wouldn't change at all. I'm moving
If somebody
with
is
the train.
inside the train and they're looking at you, you won't be moving. But if somebody is on the ground next to the train looking at you, you will be moving. So
Oh my God!
so
what
if
the
two
fuck?
things,
What kind
if
of
two
word
things,
salad is this?
if two things, the train and you, are moving at the same rate, then from the perspective of one of them, like you or the train, the other one won't be moving. So from your perspective, while you're inside the train itself isn't moving. But from the perspective of somebody on the ground, both you and the train are moving together. And that's what's happening with the pendulum. That's what's happening with the gyroscope and the pitch. The gyroscope and the pitch, their angles are tracking each other, right? They're tracking each other. Now, from somebody who's like looking at it from like a bird's eye view or whatever, they'll both be changing together. However, from the perspective of like the computer that's reading off the pitch, it reads off pitch relative to the gyroscope. And so the pitch relative to the gyroscope will be unchanged because they're moving together.
Okay, so all right. Okay, right. I mean, I hear what you're saying. I hear what you're saying, but that's not what happens.
Do you? Do you hear what I'm saying?
I think I do. Yeah.
Okay, go ahead. So how do you know that? So what do you mean that's not what happens?
So we're talking about the fuck, dude. So one more time, Blitz. We're referencing an arc angle from the nose of the plane to the horizon, right? Now you're claiming that the nose of the plane wouldn't have to drop, Blitz, which is cool. Whatever.
Relative. No. The nose of the plane wouldn't have to change relative to the gyroscope.
And okay, cool. Sure.
The gyroscopic orientation, I should say.
Who cares? I'll give you that. The only problem with that is
both of them will change relative to the surface of the Earth, I guess. Or well, they won't change relative to the surface of the Earth, but they will track the surface of the Earth, I should say.
Hypothetically, Blitz, if we're going from the North Pole to the South Pole, you get a zero inertia rate frame before you take off. When you wind up
zero inertia rate. Wait, can you repeat that? A zero inertia rate frame.
Zero inertial net force. That's what it's called.
Zero inertial net force.
Yes, when you wind up the gyroscope, you have a zero inertial rate. That's why you do it before takeoff.
What do you mean inertial rate? It's not a thing.
Do I have to fucking tell you everything, Blitz?
Where did you learn zero inertial rate from? Did you learn it from like Angel or something? Because it's not like a phrase.
Okay, 1 second. Okay, so one more time. Do you agree that you have to wind up your gyroscope in a stationary zero net force change, or no?
A stationary zero net force change? That is word salad.
No, it's not.
What is a zero net force change?
Hey, Blitz, why? All right, Blitz, why do you?
What is a zero net force change?
It means that you have a zero inertial rate. It means
what is a zero inertial rate?
It means you're stationary. You have a
with respect to what? Stationary with respect to what?
Change, Blitz.
Stationary with respect to what?
The perspective to anything, Blitz.
To anything?
Yes.
So wait, you're not moving relative to like a car that's driving by?
No, obviously not.
No, I mean you are. If it's driving by, from its perspective, you'll be moving.
That we're talking about the gyroscope, not the other person, Blitz.
That's what relative means.
Blitz, why
zero
do you think
inertia rate, zero net force.
Hey,
That's funny.
Hey, why do you think a gyroscope is wound up before it takes off?
My guess is practical reasons, so that you can have like the engineers on the ground do it.
So you don't know why?
No, I mean like it doesn't seem like it would matter actually at all.
So you don't think it matters?
No, you're right. You're right. You're right. It may very well matter because if you don't know what your pitch, so the gyroscope is how you determine what your pitch is, right? And so when you're on the ground,
what a gyroscope is. That's two separate pieces. That's an altitude indicator. You don't know
free. You measure your pitch relative. You measure your pitch relative to the gyroscope.
Do you think you can have a pitch without a gyroscope?
I guess in principle, but you need something else to measure it relative to.
No, it'll be relative to the zero inertial frame. Holy fuck, that's why.
The zero inertial. What is a zero inertial frame?
Zero inertia frame, Blitz. That's why you wound up.
Zero inertia frame is not like a phrase in physics.
Okay,
It's not a thing. So it's actually a good point. The reason why you would want to wind up a gyroscope on the ground is because you have the ground there as a reference point. So the plane, when its wheels are extended, it is flat. It is horizontal. It is perfectly oriented so that you can set the you basically have a point of reference against which you can measure and orient the gyroscope. But once you're already in the air, if you typically measure your pitch relative to the gyroscope, and the gyroscope's not wound up yet, you would have nothing to measure it against. You would have nothing to, check your orientation of the gyroscope.
It's not rocket science, dude.
Zero inertia frame. Maybe you mean an inertial frame of reference. That's what not accelerating means. A zero inertia frame is like word salad. An inertial reference frame, though, is a non-accelerating reference frame. Yeah.
It's to establish a reference orientation corresponding to the
bias of the
gyroscope.
A zero inertia frame isn't a thing. But yeah, so did you hear what I just said?
Really?
Did you hear what I just said?
Wait, you just said it.
A zero inertia frame? Yeah, I've literally never heard that phrase before, and I've read so many classical physics textbooks. Yeah.
Okay, cool. 1 second. Let's show you.
Is this going to be like plantology? Oh my god, this is so funny. This is so funny for you. Oh my, wait, hold on. I've missed all of my super chats. I'm so dumb. But this is going to be really, really funny. I promise this will be so funny. Y'all stick around 1 sec.
It's a
1 sec. This is so funny. A zero inertial frame is not a recognized or standard term in physics. It seems to be a misunderstanding or conflation of concepts, possibly related to the idea of a center of mass zero frame in classical mechanics or a zero inertial frame frequency in astrophysics.
Hey, one more time, Blitz. It's not referenced in physics because it's freaking it's aerodynamics. You know that, right? It's not physics, but
this is reference frames are a physics thing.
No, it's not. Dude, are you that incredulous? Did you understand I'm referencing a freaking acceleration or rotation a standpoint?
Okay, let's look up let's add aerodynamics to the end. Aerodynamics in a zero inertial frame is a hypothetical concept, as a true zero inertial frame is not possible within classical mechanics. The phrase most likely refers to one of two scenarios: aerodynamics in a non-inertial frame of reference, or aerodynamics in a zero gravity condition. Like it says maybe the phrase refers to one of these two things because it's not a real phrase.
With that. Hey, add gyroscope with that, bud.
Add gyroscope. 1 sec. Sorry, I have to set something up because my.
If you want, I can say the citation if you want, man.
For the zero inertial frame? I mean, yeah, go ahead.
It's literally just based off a frame of reference.
Gyroscope.
That's ridiculous, man. You're
here.
Oh, God, you're such
I added gyroscope. There is exactly one link. There's one Google result when you look up zero inertial frame aerodynamics.
It's an inertial frame of reference. It's not that complicated, Blitz.
And the only reference to zero inertial frame is when it says a non-zero inertial frame velocities. Like, it's not a real thing. You just made it up and you're bummed out that you didn't know what it were that you didn't know the correct phrase. Yeah.
Okay, 1 second.
It's so embarrassing.
Yeah, it's so embarrassing that you're that incredulous.
Oh no, I checked it for you. I was skeptical, so I checked it, and it agreed with me.
Defend your globe, bud. That's what you're doing, Blitz. It's
Sorry,
weird.
what am I doing?
You're pivoting because you can't defend your globe.
I'm not pivoting. I'm making fun of you because you said something claiming
Blitz,
that it makes sense in physics, and it obviously doesn't. Or aerodynamics, for that matter.
Frame? Wait a minute. You're telling me it doesn't make sense in physics?
Inertial frames of reference do. You said zero inertial frame, which is not a phrase. It's not a thing.
Zero inertia, what does that mean, Blitz?
It means zero mass.
Frame, add frame to that.
Zero inertia frame is not a phrase. It doesn't mean anything. The words don't fit together in that order.
Blitz, one more time. It's in reference.
Frames don't have inertia.
It's in reference of the rotation or speed.
Frames don't have inertia. Frames can be inertial, but they don't have inertia.
Okay, so it says when calibrating a gyroscope, you want to start from a known position of a zero velocity measured by gyro zero on all axis, starting point of condition, so zero rate of condition of change, meaning the gyroscope is not rotating relative to its inertial frame.
Inertial frame, yeah, there you go. Where
Oh
did
my
it,
God,
anywhere
off
in
my
there
nuts,
did
Blitz.
it
You're
say zero
such a
inertial frame
crybaby,
anywhere?
dog. You're a crybaby. It's a weird,
Did you?
dude.
I'm sorry. Did it say zero inertial frame anywhere in there?
Why are you crying though?
Oh, is this crying? Is crying what it looks like when you just get dunked on over and over again because you don't actually
First
know
of
what you're
all,
talking about?
You understand gyroscope terms, Blitz. If I asked any pilot here, they would understand what the hell I'm talking about. Inertial frame means non-accelerating,
Inertial.
non-rotating.
So look, I know what an inertial frame is. I'm very
Dude, get
familiar
off
with
my
those.
nuts. Stop crying
A
about
zero
it.
inertial
It's
frame
so
is not a
weird.
thing.
You always
A
do
zero
that. You
inertial frame is
cry
not a
because you
thing.
win a debate, dog.
A zero inertial frame is not a thing.
Let's go back to it, Blitz. Check it out. You have 44,000 feet of curvature.
Your crash out isn't going to help you here.
Blitz, if you have 44,000 feet of curvature, you have to come for a 2-hour flight, right?
Curvature isn't measured in feet.
Okay, so one more time. If there's a
How many degrees? How many degrees is this?
14.7.
14 per. You can travel 14.7 degrees in.
Or 14.4. My bad. I think.
Is that true? I mean, like maybe that's believable. It just seems like a lot.
It's
69 times 14.4. Yeah, no, okay, that's plausible. That's plausible. Sure.
It's close.
14 degrees.
Off a point or some
Sure.
shit.
14, 15 degrees ish. Sure.
Sure.
Yeah,
So
yeah.
if you're doing this without adjusting the nose of the pitch, without adjusting the pitch, right? Then I'm telling you, Blitz, you would end up eventually, if you kept going with what your math you're claiming is plausible.
All you have to do is keep the pitch oriented so that it's 2 degrees above the virtual or artificial horizon, and because the artificial horizon tracks the tangent to the Earth and the Earth is a sphere, then you have no problem. All you have to do is maintain 2 degree pitch, and you'll be fine.
We're talking about the arc angles from the nose to the horizon, Blitz.
The arc angle from the nose to the horizon. Yeah. So the nose of the plane will just track the artificial horizon, staying 2 degrees above it at all times.
Exactly,
and whatever is required to do that, it will do that, and then it will follow the curvature of the Earth.
But if you have a physical horizon that's due to obstruction, don't you think you'd have to drop the nose if you're following it as reference?
You're not following it as reference. You're using the artificial horizon.
No. So what's the artificial horizon reference of?
It uses the gyroscopes.
Which is a reference of what?
The vertical direction.
The zero inertia rate is started off.
No. The gyroscopes change over time, right?
What does that even mean?
The gyroscope's orientation changes over time. This is what the pendulous vanes were for.
It changes over time.
The orientation of the gyroscope, yeah, that's the whole point of the pendulous vanes.
A ring gyroscope? Are you talking about a ring gyroscope?
No, I'm talking about a mechanical gyroscope.
Yeah, mechanical gyroscopes don't adjust over time.
They do if you apply a torque, which is what the pendulous vanes do.
Okay, so just with a yes or no answer, Blitz, would you have to drop the nose, yes or no?
Relative to what?
Relative to the curve.
No, you would keep it level relative to the curve,
Cool.
or
So
2 degrees up relative to the curve. But the curve,
no.
as long as you keep it up at 2 degrees relative to the curve, then you'll be fine.
Okay, cool, Blitz. Now check it out. If we're going
Because if you didn't keep it relative to the curve, then it would actually end up going upward relative to the curve, right?
Blitz, if we're going from the North Pole to the South Pole, Blitz, without dropping our nose.
Without dropping the nose relative to the curve.
Sure, which means that our pitch.
So you follow the curve. Your nose follows the curve, so it doesn't drop relative to the curve, and you end up in the other orientation. Yeah.
No, so it's following the curve, but it's not dropping because of the curve.
It's not dropping relative to the curve.
Okay, so it's following the curve, but it's not.
Yep, that's what it means to. Yeah, if something is following something else, that means that they're not moving relative to each other. Yeah.
1 second, then. Okay. Now let me get my simulator out, and then that's probably gonna be the end of it. Okay, 1 sec. If it loads, we'll see it.
Yes, genuinely doesn't know what words mean. Yeah. Relative is a hard word. Relativity is hard, generally, even Galilean relativity.
Okay, so
it's just a shame because Free would benefit so much from just taking like an intro mechanics course at a university. But he never will, of course.
Well, I'm already dactated, buddy. I don't need to do that. Purity credentials.
No, it's not for credentials. It's so that you can learn something.
Oh my gosh, that's why. Damn it, Luke. What the fuck, man? All right, whatever. My homie said he was trying to fix it or some shit, man. That's why the website was down. It's actually his website that he integrated based off his own coding. So he said give him 1 second, he's gonna turn it on. So give me 1 sec, bud.
So in the meantime, would you care to account for I don't know, The Compton generator? Are you familiar with the Compton generator?
No.
Okay, you're not familiar with the Compton generator. The Compton generator is a demonstration of the Coriolis effect that you can do in a laboratory.
Can I tell you that I have an explanation? I'm not denying that as a Coriolis. I'm denying that the way that you guys claim it. The
Yeah, so
causality.
sure. What's your explanation for the Coriolis effect?
I think. 1 second. I got a paper here. Boom. This is what I'm working on right here. Is my document. Let's see your.
Is this ChatGPT generated?
No, but it is ChatGPT peer reviewed.
ChatGPT can't do peer reviews.
Yeah, they actually can. They go over my math that I put in.
No, ChatGPT is not a peer.
Okay, well, ChatGPT is smarter than the average man, so.
Not smarter than the average peer reviewer.
No,
you know how if you scroll down at the bottom of ChatGPT, it says, "Oh, ChatGPT can be wrong."
But that's kind of subjective to someone who thinks they live in a donut.
It says ChatGPT can make mistakes. Check important info. So like you got to double check this yourself. Anyway, so what's your explanation?
Thank you, Luke. I appreciate that, buddy.
Wait, hold on. Don't pivot. What's your explanation for Coriolis? I want the explanation for Coriolis.
Sure. I think it's kind of related to magnetic declination, actually. Because
so what do not so why is it that paramagnetic and diamagnetic things both experience the same kind of Coriolis effect?
They don't. That's the thing.
Oh, they don't. Is that's a claim? Can you substantiate that? Because if you could prove that, then you'd win a Nobel Prize.
Bro, you are so weird, dog. Holy shit. Hold on. Dude, what the hell? My computer's not even low. Charging. Wow, today was not the day to go live. Okay, so I guess the top outlet's not working. Yeah. So, what was it? It was an idea. I'm not. It's a working idea. I never made a claim. Blitz.
You said that you had an explanation, and then you said that the explanation is magnetic declination.
Okay, so all right,
if that's the explanation, then you would expect that it would have a different effect. The magnetic forces would have a different effect on diamagnetic and paramagnetic materials.
Okay, Blitz, real quick, man.
So if your hypothesis is correct, then you can check it.
Remember when I was asking you earlier, does a ground spin underneath a hot air balloon? You said no.
Yeah, as long as the wind is moving with the ground. If the wind's not moving with the ground, then sure. Then it will move in whatever direction the wind's going.
I would, whatever, yeah. Now, if you go to Neil deGrasse Tyson's Twitter, he states that somebody made a penalty field goal in football based off of Earth's rotation. And it was...
Why do I care about Neil deGrasse Tyson?
Well, this is the thing I get when I speak to physicists, they all give me different answers, right?
Well, so Neil deGrasse Tyson isn't a physicist. He's a former astrophysicist.
Okay, so well, he's still a physicist, yeah?
No, he was never a physicist. He was a former he's a former astrophysicist. Astrophysicists are not physicists and vice versa.
According to the guy Tyson, the guy made a field goal, counting due to Earth's rotation. It helped him during.
So I imagine he was probably referring to the Coriolis effect. I suspect that that's just false. I think that Neil deGrasse Tyson was probably just wrong.
Okay, so that's fine. That's fine. I want you to email Neil deGrasse Tyson, and I want you to tell him that he's wrong, and I want to watch you guys get it back together.
Why do I have to email him to tell him he's wrong? Why can't I just say he's wrong here?
So one more time. Listen to what I'm saying, Blitz. Okay? If Neil deGrasse Tyson, he stated he made up an equation, he derived it on live, right? It was an interview. And during that interview, he stated due to Earth's Coriolis, I forgot the number, I can play you the video if you want. He stated it was due to Earth's rotation, which I'm assuming it's a reference to Coriolis, yeah?
Yeah, that almost surely.
Oh, right on. So I got you telling me it's not. That's not how it works.
Field goal.
This is a donut, and then I got this.
Why do you keep bringing up donuts?
Because donuts stand for people who don't know shit. I call them donuts. All right.
Oh, so you're a donut?
I mean, sure. Subjectively, to your point of view.
So okay, so I think I found the tweet that you're referring to. It said today's Bengals winning OT field goal was likely enabled by a 1/3 inch deflection to the right caused by Earth's rotation. In the northern hemisphere, Earth's Coriolis force deflects airborne north-south projectiles to the right about a 1/2 inch per 50 degrees or per 50 yards. Now, I'd actually like to see the calculation that he did. It doesn't look like he actually included the calculation.
Yeah. But that's what I'm saying.
So if the suggestion is, I mean, like we could just look up the magnitude of the force if you wanted to. It's just omega cross r, right? That's the magnitude of the Coriolis effect force. Let me just make sure that that's right. Yeah, it's omega cross r, so it's twice omega cross r. So we can just look up omega is, yeah, actually, why don't we just do the calculation live? Actually, better yet,
Sure,
Free,
you know what? Do it
Free.
live, and then I
Do you want to do the
post it.
calculation live?
Sure. 1 second.
Wait, hold on a pen and paper.
Oh, you have to tell me the constants and shit. I don't know the constants.
Wait, you don't know how to compute the Coriolis force?
Not well. I know the Coriolis formula, but I don't know how to use it now.
Oh. Shouldn't you? If you're claiming that it's like you have an explanation for it, shouldn't you know how to use it?
Well, it would be. It's nothing but mass and angular velocity versus tangential velocity. It's not.
But so then why not just use it?
Because I don't know how to use it.
But wait, didn't you write a paper providing an explanation for it?
No, I haven't. I have a paper that explains the potential explanation for the causes of deflection between the northern and southern hemisphere due to the electromagnetic field.
But you don't. But you don't even know how to implement the. You don't even know how to implement the Coriolis effect, like mathematically. And yet you're claiming to have an explanation?
Well, you can get a deflection due to Earth's magnetic field in different hemispheres, just like you observe hurricanes rotating in opposite directions. You guys claim it's Coriolis, right?
This is real bad for you. Like, if you can't do a calculation, I don't know how you could potentially come up with an explanation for the thing that you're trying that you can't calculate,
first of all,
right?
It was an idea. It was an idea. First of all, it was an idea.
Mm-hmm.
It was an idea. So relax, man. All right.
So it was like a shower thought.
Pretty much.
So you're a donut with regards to the Coriolis effect, is what you're telling me.
Dude, fuck it. I'll give you that. Yeah, sure.
Okay.
Sure. Yeah.
So 40 yards is like 33 meters, right?
No idea.
I'm just doing a back of the envelope calculation here, just to see if Neil deGrasse Tyson's math is right. So that's about 30 meters per second. So it's about 1 second of travel time. So it's about
36.5 meters.
So it's about this. This is the number of meters that you would
It's
get.
not 30 meters though. It's 36.5 meters.
What's not 30 meters?
It's actually, if anything, it's 37 meters.
What are you referring to? Are we talking about the same thing?
You just asked how many meters is in 40 yards.
Yeah, I was estimating.
Yeah,
I'm doing a back of the
36.5.
envelope calculation just to see if Neil deGrasse Tyson's number is like even close to correct. If we multiply it by 100 and divide it by 2.54, we will get in inches. So I'm getting like, oh, I'm sorry, no. So I want this number. Yeah, so I'm actually getting a significantly smaller answer than what Neil deGrasse Tyson gets. I'm getting about 1/10 of an inch. But you know,
Okay.
that's within that. It's plausible that he's getting, you know, 1/3 of an inch instead of 1/10 of an inch just from like numerical factors. That's plausible, I guess. So maybe he is correct here, or maybe he was off by like a factor of 1 or of like 2 or 3.
Okay, so you're
Oh, flight time is like 3 seconds? Okay, well, if flight time is like 3 seconds, then, or if flight time is like 2 seconds or 3 seconds, then yeah, then you'll definitely see like 1/3 of an inch deflection, sure.
What the fuck? So you're saying the ground spinning underneath an airplane now? I mean, underneath a football?
The Coriolis effect is not the ground spinning underneath things.
So what's the Coriolis effect? It's an apparent force that causes deflection of things, right?
Yeah.
Cool. So you're telling me due to the ground's rotation, things are getting deflected.
Yeah, but it's not the same as the Earth spinning underneath it.
Sure. All right. So you well. Okay. So so things are getting deflected like a football.
Otherwise, just to be clear, otherwise there would be no Coriolis effect if you were like, you know, north or south of the equator. But there can be.
So the Coriolis affects footballs, but not hot air balloons.
So the Coriolis effect depends on the speed of the thing moving relative to the ground.
Is it the speed or is it the distance covered?
No, the Coriolis effect depends on the speed, not the distance covered.
I'm pretty sure it's the distance covered, not the
No,
speed.
it's not. Then you don't even know the formula. The Coriolis effect depends on the angular velocity of the rotation of the Earth, and it depends on the velocity of the thing relative to the rotating reference frame. It doesn't depend on the distance covered at all.
Well, what's the tangential velocity in reference of?
It's relative to the surface of the Earth.
Exactly. So what's the football doing when it gets deflected? What's happening?
It's moving through the air fairly quickly.
Yeah, but how is a Coriolis applied to this football?
You take the speed of the football, you multiply it by the angular velocity of the Earth's rotation, and then there's going to be a trigonometric factor there because it's a cross product and they're not perfectly orthogonal. Setting that aside, because that's a factor. It's a small factor. You multiply it by 2, and that will give you the magnitude of the acceleration.
Okay, you know what, Lolo? That's cool, man. If anyone wants to believe in a football getting beat up by
so now that I checked his math and checked that it's correct, now you're like, oh no, this is nonsense. No, you shouldn't believe this. This is too complicated.
But that's not what you said earlier. Do you remember what you said earlier? Your claim wasn't that.
My claim was that he's probably wrong, but then I looked at it and I redid the math, and it's like, oh, he's actually right.
No, your
or at least
claim was that
he's roughly right.
No, you said that Coriolis doesn't affect an airplane going from east to west, yeah?
No, I didn't.
Oh, you didn't? Because last time I checked, you said it stayed.
No, I said that. So to be clear, there will be a Coriolis force on anything that's moving. That's not moving in a direction that is. Like if you're moving north-south at the equator, then you won't get any Coriolis effect because the vectors are aligned. But in any other direction, there will be a Coriolis force. However, the question is whether or not that affects travel times, for example, and it doesn't.
Okay, so
because aircraft maintain constant velocity, so forces aren't really relevant here.
Okay, according to your NOAA, man, right, which is right here, states the top of the poles is going about 0.0005 miles per hour. The equator is about.
Wait, the poles don't move. They don't spin. Or they do spin. They don't move.
Okay, well here it's spinning about 0.0005 miles per hour. Are you gonna argue?
Yeah, I guess if you're near the poles, then it will spin.
Why? What the hell wouldn't it spin?
I'm sorry, not spin. It will move. Spinning and moving are different, right?
So if I have a basketball and I start rotating it on my pointer finger, you're telling me the bottom of it's not spinning?
It's spinning. It's not moving, right? It's not like moving through space.
What the dude? Whatever, man. That's boring. Can we go back to the airplane?
I don't think so, actually, because you've already been stuck on the airplane for an hour and a half. No, I'm just ending the discussion with you because we've gone over two kind of three of your things, and you failed to make a point on any of them, and you've been on for an hour and a half. So no, I'm just ending the discussion. Anyway, we do have some super chats to go over. Let's read those really quick. And we also have like 10 guests waiting right now, so we got to get some of them. So from Helping MAGA Deconstruct with the $2, a snowflake flatty, please don't gaslight me. Yeah, fair. And then from Helping MAGA Deconstruct again with the $2, thank you. Little buddy, stop embarrassing your parents. Oof. From Anarchist with the $5, Blitz isn't even debating with humans anymore. He's arguing with ChatGPT drones. I know, it's rough. And then from Dave Mon with the $5, thank you for the gift. Thank you for the try again. Econolodge with the $2. This must be the Florida man. It is. That was the Florida man. Bubblemint with the $5 says Blitz, Blitz, Blitz. Yeah, somebody kept a counter and he said my name like 200 times or something. Garbagaman says with the 5 Canuck bucks says Plantologist, the derivative of A to 0, Blitz. And you said Ian was wrong for saying 0. Plantologist, haha, typical. Yeah, that is what happened. Yeah. From Go Get a Mods with the $2, the fuck does the wind have to do with the Earth being flat? Yeah, it's a good point. It's a good question. From Jim with the $2, I've been to Chile, Antarctica, no way Earth is round. Chile and Antarctica are not the same place. And from Helping MAGA Deconstruct with the $2, can we ask the plantologist about the ice wall? You can ask him. Now we do have a guest on YouTube. Let's see if we can bring him up. Amir, can you hear me? Amir? I know I can hear you. He's in a lovely sunroom. Where is he? Ooh. Amir, can you hear me?
Yeah, can you hear me?
Yeah, I can. Welcome. How are you doing?
Yeah, hello, can you hear me?
I can hear you. Can you hear me? Testing.
Can you hear me, mate? Hello, testing 1 2 3.
I can hear you. Can you hear me?
Hello, testing 1 2 3.
This is your audio. This is your audio problem.
Testing 1 2 3.
I can hear you.
I can hear you, yeah, but can you hear me?
Yes, I can hear you.
Yeah, not too bad. Once...
Oh, no, there's an enormous delay.
Sorry, I had the YouTube playing at the same time, so let me just pause that. It should hopefully sort out the echo that I'm hearing. Am I still on the line?
Yep, you're still on the line. You have to listen through the app, through the website.
Oh shit, sorry. Dude, one second. Can you hear me now?
I can hear you just fine. He's working on it.
Pretty weird.
He's working on it. Let me check his audio settings.
Mate, that's really, really strange. I can't hear you. I could hear you when you were in the YouTube room, but I can't hear you as we're in this.
Can you hear me now? Can you hear me now?
Worked.
Can you hear me now? Can you hear me now? Testing.
Right. I've just tested my audio. I'm sorry if you're speaking and I'm speaking over you because I can't hear you right now. My audio seems to be working fine. My audio source.
He's not playing the sound through the app. He's not letting the app send sound. All right, let's bring up another guest. Let's bring up Jared. Sorry, Jared. I think that he's back. Feel free to get back in the queue, Jared. I'll bring you up next. Can you hear me now, Amir?
I can hear you just fine.
I can't hear you, by the way.
Oh, shit.
And he stepped away.
Shit.
Can you hear me?
Oh, here.
I can't hear you.
I can hear you.
I don't know why I can't hear you. That's actually on my end. I should be able to hear you. Try again. Okay, I can hear you now. You're good.
Testing.
Amir. Lovely. So,
perfect.
Sorry about that. Do you think the Earth is flat?
I don't think the Earth is flat. No.
But then why'd you join?
I'm very far away. Well, I just had more of an observation. I mean, the first instance, I was just trying to ascertain what exactly is the purpose of your call-in show.
To show that flat earthers don't know what they're talking about.
And who are you trying to show that to?
Everybody else.
To the flat earthers.
So Amir,
right?
Okay. So this is an example of tone policing, which I will have none of, by the way. Sorry, I know you waited for a very long time, but I'm not gonna explain why I'm doing the live. Somebody who, anyway, yeah, that was rough. Let's talk to Jordan. Yeah, I know, all that for nothing, right? Jordan, how's it going? Jordan?
Oh, yeah, my bad. Didn't mean to join.
You're good. All right, we have $2 from Chase. If the Earth is round, why are shoes flat? Got him. And then from Dexter with the $5. Blitz's mic keeps disappearing. This is all Hollywood fuzzy math, zero inertia framed Roger Rabbit. True. All right, let's bring Jared back up. What happened to Free? I kicked him because we had gone on for an hour and a half and we weren't really making any progress. Jared, how's it going?
Good. Can you hear me?
I can. Are you a flat earther?
Yeah.
Okay. And why would you say so?
Well, I guess there's not a lot of evidence to prove otherwise.
What's your standard of evidence? Yeah, go ahead.
Would be images from, or I should say, photographs from space.
Oh, why do you think that there's not a lot of photos
of the Earth?
Sure, there are. Plenty were taken by the Apollo missions. No, there are plenty of photographs taken on film.
There are zero on the internet.
I can show you one.
I cannot find one that is not rendered.
Want me to show you one?
Sure.
Apollo 11 blue marble. Open in new window. Open image in new tab. There we go. Just gotta. Here it is. Yeah. Can you see that?
Okay, so where are the stars?
They're washed out.
So perfectly?
They're washed out. So that means that the exposure is not high enough to capture them.
So, but they caught the Earth.
Yeah, the Earth is a lot brighter than the stars.
The Earth is brighter than the stars.
Yeah. The stars are very far away. So there's a photograph. You asked for one. Now you have one.
I don't know. I really, photographs can be doctored. So can images.
But hold on. You said that there are no photographs. I just showed you a photograph.
I would like to see the link, and I would like to just go study it. It would.
Yeah.
I mean, it's
in
tough
fact,
for me to just look
I think
it
that
up
this photograph
and then,
is actually on display in a museum. Let me double check that. In fact, maybe even the negatives are.
and I guess while you're looking at that or for that, why did they lose all the telemetry as well as all the videotape?
Hold on, just to be clear, we're not gonna shift. But okay, so it looks like the original Apollo 11 films and photos are carefully stored at NASA's Johnson Space Center. But all of the photos are available online in a digital archive, so you can go scroll through them there.
Sure, I'll check that out.
Yeah, they're available at. I know that there's a way to find them. Well, anyway, you can Google. You can look for like Apollo 11 photograph archives or something like that, and you'll find them. And there's also video, by the way, from like the same missions, from the same of like space and the Earth and so on and so forth.
Yeah,
I think
video can be edited and doctored and
in the 70s.
But I don't know why did they have an actual director? There's a lot of stuff.
So just to be clear,
from the president.
Just to be clear, so you asked for evidence of photos. I gave you one. In fact, you could there's like hundreds.
I don't know if those are real. I really don't.
What would you need to see in order to know that they're real?
I'd have to see the actual film.
Like you'd have to go in person to see it?
Probably.
Are you willing to do that?
Not right now, but I mean, if I really wanted to know that bad, I would.
Which presumably you do, right?
Evidence.
Because you think the Earth is flat.
Well, why don't they ever show live feed from the space station?
There is there is literally a live feed from the space station going right now.
But
I can pull that up for you too if you want.
Is it showing curvature of the Earth?
Probably, but I imagine that you will just call it. I'll imagine that you'll probably call it fisheye lens or something. Which to be fair, from 250 miles up, there's not it wouldn't be as dramatic as it looks, and that is because of the lens that they're using. But yeah, I can show you a live feed right now from the ISS. Let me pull it up
with curvature.
Well, no, I mean they're not currently pointing at the horizon, but I can scroll back and see if I can find a place where they were pointing at the horizon.
Stuff like that. They have rovers out there. Don't they have stuff that's up there higher? Supposedly there's something.
Yeah. Okay. Hold on. Here's a live feed from the ISS. This one shows curvature. It's probably exaggerated, but actually, no, it's not exaggerated. It can't be because it's pointing the other direction. Let me pull it up really quick.
Is it? What kind of camera are we talking about here, though?
Well, the point is that the curvature is on the lower half of the screen. So if there was barrel distortion, you would see curvature in the other direction. This one's obviously distorted, by the way.
Yeah.
So
exactly.
No, but the earlier ones weren't. The earlier ones weren't. They were on the other side, right? They were on the other side of the camera. Do you not understand how barrel distortion works? Barrel distortion makes it so that flat things, if they're in the top half of the frame, they curve this way. If they're in the bottom half of the frame, they curve the other way. But we're seeing something in the bottom half of the frame that's curving in the wrong direction. So yeah, there's live feed from the International Space Station, like you asked.
Okay. And then why don't they allow people to go to Antarctica? Don't tell me
they do
the little surface area where they allow
you can book a private
cruise.
You can book a private expedition. Yeah. There are various companies that will do it. You can even go to the South Pole.
Yeah, but
these are private organizations with their own private airports on Antarctica. They're not like some government ran organization or something.
But you can't just go explore on your own.
You can. You'll probably die. But yeah, you can. In fact, several people have. In fact, a lot of people do.
So what was that treaty all about with all the countries?
The treaty was about who controls it, right? That nobody's allowed to build military installations there, that nobody's allowed to claim sovereign territory there, that kind of thing.
Mm-hmm. Interesting. And then I guess the last point, and I'm gonna go look all this stuff up. You know, I'm still not 100% convinced. I'm trying to figure out why there's certain things that are just very hard to find. And another one was, you know, there's certain cameras. I forget the exact model. They discontinued it, right? And a lot of people's conspiracy theory because you know it has such a long range and that it was capturing.
You're talking about the Nikon P1000 or something? The FLERFS P1000?
I forget the exact model number.
Look, so here's just to assuage your worries regarding the conspiracy theory of the Nikon. Any telescope that you buy will be better than the Nikon P1000. Literally every single telescope will be able to show you images further, will be like able to zoom in more than the Nikon P1000. So it's not some conspiracy because the Nikon P1000 was zooming in too far. Literally any telescope will do better.
Sure. So I guess my question is this: do you know at what point the Earth would curve based on the dimensions that are currently known about the Earth? Like how?
What do you mean at what point? The Earth is a sphere, so it's curving everywhere, right? That's what spheres do.
Okay, so at what rate, right? Like how far? Like in
1 degree
mile,
every
how
69. 1 degree every 69 miles.
1 degree every 69 miles. So
Yeah.
what does that come into, like actual inches or
curvature isn't measured in inches, it's measured in degrees, right? Curves turn, and so you measure the amount that it turns in degrees.
Okay, so I guess some of the points that have been trying to prove with these long distance lenses, and I guess you say microscope, telescope can do the same thing.
Telescopes can like do way better.
Right. So would you agree that across Lake Michigan, one of the lakes there, that there would be curvature enough to be noticeable?
Yeah, that's why you can't. Yeah, that's why you can't see, for example, the streetlights on the other side of the shore. Yeah, because they're obstructed by the curvature.
Are you? Well, the photographs that I've seen, they're showing buildings on the opposite side that level.
So absolutely, you can see buildings because they're very tall buildings in Chicago, but you will never see the streetlights.
Level.
I don't know what you mean by level. Ground. You can't see the ground you can't see the ground in those photos.
I thought I'd seen photos where it was just a straight shot of the skyline, and there was.
You can see the skyline across the lake because you can see some of the skyline.
The bottom levels.
How do you know that you're seeing the bottom levels? If you're seeing the bottom levels, why can't you see the streetlights?
You can see the streetlights.
Oh, you can't. You'll never find a flat earther that tells you, yeah, you can see the streetlights across Lake Michigan. You'll never find it.
I guess I didn't come as prepared for this. I just saw your
that's fine
feed here, and I wish I had some of the pictures.
Let me show you a photograph from.
Loaded up.
Yeah, I got something for you. Yeah, so I just Googled Chicago skyline from across Lake Michigan. Pretty standard Google. So like, here's the kind of photo that you get, right? And yeah, you can see the tops of some buildings, but there's no way that you're seeing streetlights, right? And like, you know, here's something that's like perhaps more zoomed in. This is from Michigan City, so it's slightly closer. Here's another, but like you're never seeing the streetlights, right?
Well, how many miles is that?
It just depends on where you're taking it from, right?
Like these photos, like is this?
I mean, I would have to go look where the photos were taken from, but yeah, most of these are going to be. I mean, like we're looking like across the lake. You can tell that the lake's in the wake, so you can see the water. And so, like, clearly they're on the other side of the lake. It just depends on where they are. And the distance will be different. Wait, if they were closer, they should be able to see more, right?
That's what I'm saying. Like, I don't know exactly where that shot is and how far it is.
So, look, the point is that you will never find a flat earther who will produce a photo of the Chicago skyline, like a verified photo, you know, where they like geolocated it or whatever, where you'll see the Chicago skyline. And the streetlights. You'll never see it. You'll never find it.
Okay.
Now, by the way, on the other hand, here's a photo that was just like, this was taken from a boat, right? Like we can pretty clearly see that this is very different than this. Right? These are like very different. You can see a lot more buildings in this one than you can in this one. You can see a lot more buildings in this one than you can in, say, this one. Because like the ocean is obstructing it in this one, but it's not obstructing it in this one.
Yeah, I mean, I don't know where that second one was taken from. It doesn't say.
This one was this one says across Lake Michigan. You mean the one that where you can see it?
Yeah.
It doesn't. Are you saying that you're skeptical that this one was taken from a boat? That maybe it was taken from across Lake Michigan?
I don't know. What does it say? Does it stipulate?
I mean, you can see that they're on the water because like you can see the water that they're on, right? Like down here, you can see like the ripples in the water. Whereas like
I see ripples,
in these,
that doesn't mean they're in the water.
in these, I mean, like you can actually just compare sizes, right? Just the relative sizes of these buildings are much bigger here than they are here, which means that here they're much further away.
I don't know what the magnification is that they're using. You know, I don't know what camera they're using. You know, there's so many questions. It's hard to debate those images, I guess. You know, unless you're taking them yourself or you have more evidence of the camera.
Have you taken them yourself or been there?
No, I would like to. It was something.
So then why'd you bring it up if you can't know?
Because I heard about the P5000 or whatever.
Right, but you've never been there, so like there's no way you can verify any of the claims.
True, but I just feel like there's been a concerted attempt to not allow flat earthers, and I think the one instance that really made me want to look, because I thought they were ridiculous, right? I thought flat earthers, I thought that
as you should,
concept was ridiculous, right? But why was YouTube taking those videos down? Why were they making an effort to squash the flat Earth?
So I mean, look, so. Is there something that you think is true? Like, do you think that like, I don't know, do you think that like chemotherapy is good for, or is good for at least getting rid of cancer or like helping get rid of cancer?
Along with killing the rest of your cells.
Well, yeah, chemotherapy is toxic, but like, you know, do you agree that it's at least like somewhat effective at like getting rid of cancer sometimes?
I don't know if it gets. I don't know. I've never had it, but yeah, I assume that it had some.
Oh, okay. Let's back up then. Do you think that like antibiotics are good for like dealing with bacterial infections?
Yeah.
So like, if you're YouTube and you see that like there's a whole community of people who are posting videos that are like, antibiotics will kill you, don't take antibiotics, you wouldn't want that on your platform, would you?
That's not a good analogy.
I mean, it's just spreading false information, right?
But that's putting people at harm. That's different.
I mean, if you have a view,
you should be able to have freedom of speech.
You have freedom of speech. You don't have the right to use YouTube. YouTube's not a public utility. But anyway, that's neither here nor there. The point is that YouTube has a policy.
YouTube, right?
YouTube has a policy of well, to be clear, they don't remove flat earth stuff anymore. They just delist it, so like it's harder to find. But YouTube has a policy of like not prioritizing misinformation, which I think is generally good. I think it's a good thing to not like allow like viral misinformation to be like on top of correct information, you know?
See, I don't think that there's any issue with somebody expressing an opinion about stuff like that. Right, really
but the videos are not expressing opinions. The videos are not expressing opinions. They're saying they all lied to you. This is how it actually is. I'm telling the truth. They're not expressing an opinion. They're not saying, you know, in my view, the Earth is flat, but it's just an opinion. They're not saying that. They're not doing that. They are intentionally, arguably spreading disinformation. Intentionally. Well, I don't actually think that they're lying about that they're like intentionally lying, but they are intentionally trying to convince people that their opinion represents reality. And I think that that's generally bad. I think that, you know, we shouldn't, would you want, let's say something that doesn't really matter. Are you a Christian?
No.
Okay. Would you want a teacher in school telling everybody that Jesus rose from the dead?
No, because I think there should be separation of religion and state.
Would you want So you're okay with preventing, but what if it's just the teacher's opinion, right?
Look, you're saying you're essentially saying that you're not allowed to have hypotheses and theories in
It's
school.
but
because there's
to
a
be
lot
clear,
of
that's not what
theories
those
that
are.
aren't proven.
The flat Earth isn't a hypothesis. It's not a theory, because it doesn't. There's nothing scientific about it, right? They're not actually running experiments. They're not actually doing data analysis. They're not actually making predictions and checking them against observations. The point is that if you intentionally spread misinformation, then you're hurting people. Whether or not it's direct harm or indirect harm, I think that spreading misinformation is generally pretty bad. I'm sure you agree. You just think it's weird that YouTube is taking that seriously.
I just don't know. I really don't know. I mean, I've heard that most of what the pilots and what they have, the understanding of a level flat Earth is the way that they are, as the way that they navigate.
So
right?
if you ask pilots, I would bet you that like 99% of them think that the Earth is round.
When they're flying around the world, say you're going from the United States to Europe, they state that there is no changing of the level of the nose on the plane. Like they're not.
Well, they don't have to do it. They don't have to do it manually. Yeah, they don't have to do it manually. Some of the features of the way that planes are designed, either intentionally or unintentionally, based off of the location of the center of lift and the center of mass, produces a torque on the plane when it's not flying straight. And so if your plane was flying straight and then it never changed and then it got around to the curve, it would now not be flying straight over that part anymore. It'd be tilted up, and so there'd be a torque induced on the plane. And so like there are like passive autocorrection mechanisms.
You're saying that it is dipping slightly as it's moving.
Yes, of course it does.
But that's not what I've heard. The planes are.
They don't have to. They don't do it automatically. All they do is they don't do it manually. What a pilot's job is to do when they're cruising is just to make sure that the nose is pointed, however many degrees above the artificial horizon as is necessary. So if there's turbulence, that'll tip the nose up, it'll tip the nose down, they'll adjust. If there's wind, that'll tip the nose up, tip the nose down, they'll adjust. Whatever happens, they adjust. That's what planes do, so that they keep flying level. And if that means that if what that means is that as they fly, they have a gradual tip up, well, they'll gradually tilt it back down to get it back to where it needs to be. They have no way of telling the difference between. They have no way of telling the difference between turbulence, between wind, between the curvature of the Earth. All they want to do is just keep the plane level.
Yeah, I've heard they just fly in a straight line and they're not actually.
Then you haven't talked to many pilots then.
No, I haven't, but I will. I'm gonna bring that question up.
Okay.
Oh, cool, man. Well, I appreciate you being straightforward and giving me some good evidence. I'll go and do my research. I'll jump back on sometime.
Sounds good, man.
If I find anything, appreciate it.
All right, take care. All right, let's read some super chats. I think we have some. From John Jackson with the $2, just send in a $2. Thanks, man. From Nectu with the $10, if it's so easy to Photoshop a real-looking image of Earth, then where's the flat Earth equivalent? Every image of the flat Earth actually is CGI and looks like it. Yeah, that's true. That's actually a good point. And from Mindas with the €2, flat Earth is a Nikon marketing campaign. Absolutely true.
It's one of the most important essential.
Flat Earth conservative, are you there?
The most important keys for Victoria. I mean,
Guess not. All right, let's bring up another guest. Let's bring up Delmar. Delmar, how's it going?
Hey, man, I just wanted to say that I just watched that whole discussion, and the only reason I asked to join is because I just wanted to say you absolutely smashed that guy.
I appreciate that, Delmar, but I gotta let you go because it does say opposition only. Let's talk to Bong Water Enjoyer. That's classic, classic Flat Earth. Bong Water Enjoyer. Why are we discussing this in 2025? Because some people think the Flat Earth isn't dead. I'm just here to tell them that it is. All right, let's talk to Shine333. Shine, how's it going?
Oh, sorry.
Can you guys hear me? TikTok, can you guys hear me? Okay, why is everybody saying, is your mic working? Sherry, how's it going? Sherry? Sounds like it's not coming from the mic. Oh my god, really? Has it been? Oh my god, that feels so dumb. This is probably so much better now. How's that? Is that better? How embarrassing. It was coming from the mic on YouTube. But yeah, that's awkward. I should have checked. Sherry, can you hear me? All right. Yeah, sorry. No, YouTube was fine. It was TikTok that was done. That was dumb. Oh well. It's Honey, how's it going?
It's going great. How are you?
I'm doing all right. Do you think the Earth is flat?
I don't think it's flat, but I'm completely confirmed that the heliocentric model is fable.
So when you say the heliocentric model, are you referring to, does that include the shape of the Earth, or?
No, the Earth is spherical as far as I can tell. I think the analemma shows that because it shows the sun going around the Earth.
Okay.
But what the universe presents to us, Doctor, is binary stars, binary and multiple stars. And yet
Look,
we're
so,
supposed to believe
Honey,
that
the topic is the shape of the Earth. So like, if that's not what you want to talk about, then it'll have to be another time, another place. By the way, if you're watching on YouTube or on TikTok and you want to get notifications about when I'm live, for example, or when I put out new videos, join the Discord server so long as you're 18 plus. If you're watching on YouTube, there's a link in the Discord, in the description of the video, to the Discord server. If you're watching on TikTok, click on my little profile somewhere over here. And there's a Linktree link. And if you copy and paste the Discord link in the Linktree link into a browser, you'll get right to the Discord. So make sure to do that. And let's bring on the next guest. Let's bring up Caleb. Caleb, how's it going?
Hey man, how are you?
I'm doing all right.
So,
you think the Earth is
I'm
flat?
not a flat earther, but
not?
I'm willing to give you a good argument about it.
Nope.
To pretend like I'm a flat earther.
Nope, I don't want you to pretend. I don't want none of this pretending. Pilot, can you hear me? Pilot. All right, Pilot's not here. All right, let me double check on something. Seeker, can you hear me?
Hey, Dr. Blitz.
Yeah.
So, I'm
Do you think
a
the Earth is flat?
flat earther. Yes.
Why is your video on but black? Can you turn your video on?
I want to ask you one thing.
Nope. I know who this is. I have a troll who likes to, you know, spam and dox and stuff. So, no, it wasn't Will. Brazy, how's it going?
We live in a Jupiter-centric planet.
Brazy. All right, let's read a super chat because I think that we have a few. It wasn't free, no. From Nobody on Fire with the $10. Blitz, I made a graph after your debate in the FLERF server. Is my math right that if the Earth was flat, the receptor of the Dune experiment would have to be 40 miles underground? Something like that. And yet, the whole and this is something I didn't. This is something I actually didn't mention in the flat Earth debate, which I should have. They can actually measure the neutrinos coming up from below it, right? They actually can measure the direction in which the neutrinos are going. And so even if the Earth was flat, and it was a result of the divergence, they wouldn't see the neutrinos coming up from below. They would see them coming down from above because it's slightly underground. So yeah, it's absolutely the case, yeah. All right, let's bring on another guest. Let's bring up Focal Point. Focal Point, how's it going?
It's going well, Dr. Blitz. How are you, sir?
I'm doing all right. Glad to hear it. Do you think the Earth is a globe?
Well, I know it's a globe, sir. I just wanted to discuss how little g is determined by big G objectively and very easily.
That's great, but it does say opposition only behind me, somewhere up here. So I do appreciate it, but I should make my head bigger, or my head smaller, rather. There we go, so I'm not blocking anything. There we go. Earth is flat. That's why you're not allowed to take a commercial flight to the moon. True. Absolutely true. I respectfully oppose. Okay, Commander, come on up. Why'd I boot him? Because he isn't a flat earther.
Yeah.
Commander, do you think the Earth is flat?
Yes.
Okay,
yes.
great.
Well, I do, because in construction, we used to build bridges, and no matter how long that bridge is, we use a laser straight line of sight. And so no matter how long that bridge is, we never had to adjust for the curvature of the Earth.
What bridges did you build? What bridges did you build?
I'm sorry?
What bridges did you build?
Oh, gosh. Well, I didn't know the name of the bridges.
You didn't know the name of the bridges? I mean, if these are big bridges, are these big bridges where they where you would expect to see the curvature of the Earth, or are these just like?
They weren't giant bridges, but
how long were they?
They were part of a series of roads and bridges.
How long were they?
And then other times we worked on the highway.
How long were the bridges?
The highway was relatively straight, like in Kansas, the roads are straight and long as hell. And we never had to, we always had to consider the flow of water. But
hold on, I'm just a little confused. I'm just a little confused. So you say that you used a laser level. How far did you shoot it?
Oh, gosh. Well, each job was different, but...
Like, give me an example.
Quarter of a mile, half a mile sometimes.
So how much would you expect the laser to change its position over a quarter of a mile?
Well, I don't expect it to change at all, because...
No, I mean, like, if the Earth was if the Earth was a globe, how much would you expect its position to change?
8 inches squared.
Okay, so give me the number. So how much over a quarter of a mile, how much would that be?
Well, 8 inches over a mile, 8 inches squared over a mile.
It's not 8 inches squared. It's 8 inches per square mile.
Squared, which is 64.
It's not 8 inches squared. It's not 8 inches squared. It's 8 inches per square mile.
Per square mile.
Yeah. So it's 8 inches per mile squared, you could say. Either one works. So given that formula, how far should the laser dip over a quarter of a mile?
About 2 inches.
So now you're doing your math wrong. So what you have to do is you have to square the distance.
A quarter of a mile?
You square the distance and then you multiply it by 8 inches.
Okay.
So what's a quarter? What's a quarter squared?
Take your answer and apply it, and it still didn't do that.
No, we're gonna do this together, Commander. Commander, we're gonna do this together. So what's a quarter squared?
25 squared.
A quarter squared, not 25.
Well, a quarter is like 0.25.
Yeah.
Yeah.
So what's that squared?
So it's 0.25 squared.
Yep. What is that number?
Well, you have the calculator. Spit it out.
Don't need a calculator.
Okay, spit it out.
It's 1/16, right?
And it still isn't.
So
It
so
still
you take
isn't used
1/16.
in
You take
linear.
so
It's
commander, hold on. So you take 1/16, you multiply it by 8 inches. So how much drop should you get over a quarter of a mile?
1/16 multiplied by 8 inches.
Yeah, how much is that?
Whatever is.
How much is that?
I don't have a calculator on me. You go ahead.
You
and
don't need a
calculate.
calculator for this.
Okay, well, go ahead and do it. Answer your own question.
It's half an inch.
Because regardless what your answer
it's half an
is,
inch.
we had to have a straight line.
Right.
And,
so
and
it's
that's what the
half an
laser
inch.
Does. The
so
laser does
now,
not bend.
Commander. So it's half an inch, right? So if
Okay,
the Earth were a
half an
globe,
inch.
you would expect half an inch of drop over a quarter of a mile. Now, you were using a laser that a standard construction laser, right?
Yes.
Okay, so let's go find the divergence of standard construction laser. This is something that we can look up. 1 to 2 milliradians is pretty typical. Let's use the smaller end of that. So that tells you how much the beam expands, right? Because the laser gets wider as it gets further away. So if it's 1 to 2 milliradians, we can just calculate how big that laser beam would have gotten over a quarter mile. Is that fair?
Yeah.
Okay. So do you know how to do that?
Know how to do what?
Figure out how much it expanded over a quarter mile.
We were never required to know how far it expanded. What's the radius of the expansion?
So this is pretty easy to find. So it would have expanded by 0.00025 miles. So we can multiply that by 5,280 to get it in feet. So a quarter mile away, the laser beam would be about 1 foot 4 inches across. And you're telling me that you notice the difference between it being half an inch higher half an inch higher than it should be?
The radius. That would be the radius.
That's the size of the laser beam. Yeah, it'd be about this big. Be about this big. And you're telling me that you would notice the difference between it shifting up by half an inch as opposed to down?
Yeah.
I don't think that you did. In fact, I don't think that you've ever used. I don't think that you've ever used a construction laser over a quarter of a mile.
Wow. Okay.
The size of the beam is far too large. Yeah. So
it still does not compute the curvature of the Earth, sir.
Well, so then why did you lie to me?
I didn't lie to you.
So you said that you've used the laser.
A laser you're not familiar with.
So wait, so you used the laser?
We used several different lasers.
Okay, what color was it?
The big construction type of laser that costs a few $100, and then for smaller projects we use a smaller laser.
What color was it?
Yellow.
You used a yellow laser. Now I know you're lying. I know you're lying.
Are you talking about the machine? The machine normally the machine.
No, I'm talking about the light. I'm talking about the light.
Oh.
What color was it?
Red, I believe. It's red.
Oh, you believe? You don't know?
Yeah, it's normally red because it's red. It's a red
I don't think
laser.
that you've ever actually been on a construction site where they used a laser over a quarter mile. I don't think that that's true.
Okay. Well, even if you don't believe it's true, it's not required. Your belief is not required.
Well, I think you're just lying to me.
The Earth, when we calculate bridge or
can you provide any evidence that you've actually been on such a thing? Like, can you pull up a picture of you at a construction site where they're using a laser?
Let's see if I can.
Just set it as your background and then turn on your green screen. Yeah, it probably will be. It won't let me put the picture up. That's a good point. Welcome back.
Thank you. Like I said, I've got a picture of me on a construction site, but I'm not holding a laser.
Can anybody else see anything? Because I just see a black screen.
Okay. How again did you tell me to put the picture on there?
Make it your background.
Make it my background.
Yeah, so go into effects, and there will be like a green screen thing. And you can make it your green screen.
Effects. Where is effects located?
Should be somewhere, like you click on your camera thing, and then
Camera thing. Click on a camera thing.
you'll have to turn on your camera.
Well, I'm on I see your site here. I don't see a camera button. I see a mic button. I don't see a camera button.
It should be at the bottom right. There should be a little
Bottom
camera
right?
icon. It's like a square with a triangle on the right.
Okay. A square with a camera. I don't
With
see that.
It's a square with a little triangle off to the right.
Okay. Like I said, I don't see that. I see an arrow, a gift box, a rose.
Here, let me disconnect you, and then I'll reconnect you. So go ahead and rejoin. We can fix this. Where is he? All right, he's not, I don't know if he's coming back. No, I kicked him because his video was like not working. All right, let's bring on Skybuster. Skybuster, how's it going?
Good.
Do you think the Earth is flat?
I don't know what to believe.
Do you think the Earth is a globe?
Not anymore.
Okay,
I
why not?
just think it's all full of lies. And
Why?
there's just both sides.
There's just both sides. What both sides?
What I see and hear just doesn't compute. Like, so you were showing those pictures of across Michigan, Lake Michigan or whatever.
Yep.
And you see, so you're telling us that you can see it drop away, right?
What I said is that you can see the tops of the buildings, you can see some of the very tall buildings, but you can't see like the streetlights.
But that's because it's supposedly falling away from you, right?
Well, it's because it's curving away, yes. Because there's water in the way.
There's no curve on the side? If you can see curve that far, how come you don't see curve on your, on the horizon to your left and right? Why is that always flat all the way?
So just to be clear, so you can, depending on how far away your horizon is. But when you're standing,
you're
like
looking at it. In that picture, you can see it.
I'm explaining. So when you're at sea level, which if you're standing on the shore of Lake Michigan, you're at sea level roughly anyway, or you don't actually have to be at sea level as long as you're like level with the water, right? So your horizon is about 3 miles away if you're like 6'8" like I am, right? It's about 3 miles away, and 3 miles away, that's not very much curvature. It's like a 1/20th of a degree of curvature, and our eyes just really aren't that good. However, when you are looking at the distant horizon, what you're seeing is something that is 50 miles away, 60 miles away, however far away it is. And so in that case, because it's so much further away, you are going to see the effects of curvature because it's able to accumulate over a larger distance. But the horizon that you see is only a few miles away. It's like 3 miles away. So it's just a matter of scale. You're seeing a more significant effect forward, backward because you're looking at something further away. The horizon is only 3 miles away.
Yeah, but I live like on the Oregon coast, so
I'm sure.
I'm just saying, I have a really nice, awesome camera, and you can just zoom out there, and I can zoom out to my left and right, same time, get way the hell out there with nothing.
No, the horizon. It doesn't matter how much zoom you have. The horizon will never be more than 3 miles away unless you're like on top of a building or something. That's related to how tall you are. Now, the reason why you're able to see tall buildings past the horizon because
you can only see
keep in mind
where the sun's at.
What?
You can only see it where the sun's at. Is what you're trying to tell me?
No, it has nothing to do with this.
That's the only time I can see.
No, that's not what I'm trying to tell you. What I'm trying to tell you is
Then
that
how come I can't look all 4 directions at once on a spot like that and see drop in every direction?
you're only able to see the horizon, right? Like when you're looking for the shape of the Earth at the horizon, you're looking at the horizon, and that's only a few miles away, right? The horizon is only a few miles away.
But not in a camera.
A camera doesn't change the location of the horizon.
Okay.
The objects that you're seeing, so if you take a camera and you zoom in on the Chicago skyline from across Lake Michigan, the objects that you're seeing are not at the horizon. They're much further away than the horizon, right? They're like 60 miles away, whereas your horizon's only like 3 miles away. What you're seeing is you're seeing them peek up from behind the horizon.
So I don't know. That's confusing.
We grant that.
Seem right. I don't know.
Okay.
I just don't trust. I don't believe in anything as much as I believe in anything anymore. The whole thing is just there's too much on both sides that don't make sense. It could be a triangle for all I know.
I mean,
I think everybody just takes in what people tell them, and everybody just runs with it.
The shape of the globe is like pretty well verified because like we just have photos, right? Like it's a pretty straightforward way to verify it.
I mean,
we have live streams, in fact, from space.
Walk around it. I mean, how can you really tell me that?
We have live streams from space.
I mean, are they?
Yes. Yeah, they're live
you
streams.
Believe and trust everything, huh?
How are they faking a live? How are they faking a live stream?
Religious?
How are they faking a live stream?
I mean, AI. It's computers. It's technology.
The live stream's been live since like 2015.
You believe that everything that's going on in the world is like true and told? You know, like there's not like indoctrination, not slavery. There's not like man.
What does that have to do with the live stream? There's a live stream.
Yeah, but it's corrupt. It doesn't make it right or logical.
What do you mean? It's just not even plausible to. It's just not even plausible. By the way, it's just not even plausible to like fake a live stream. Like that tech didn't exist until like maybe last year. I don't know.
To you, but it exists to people in charge, doesn't it? You think
no.
They just like we get the top knowledge stuff out of the gates?
Most of it, yeah. There's some like advanced military tech that I'm sure we don't get, but like yeah, most of the tech, yeah, most of the tech that's developed by private industry, yeah, we get immediately.
So what do you think of NASA?
What about it?
You think they're really just a space? You know, you
yeah,
believe
they're a space agency,
all
yeah.
that stuff?
They're a space agency, yeah. They went to the moon about 50 years ago.
But that's saying, yeah.
We have really solid evidence that that's the case. We left retroreflectors on the moon. You can bounce lasers off of them.
Okay. I mean, I get that.
How did the retroreflectors get up there? How did the retroreflectors get up there if nobody went?
I don't know any of that.
Okay, so you can bounce a laser off of a mirror that was left on the moon.
Like you're just telling me something that you're told. You don't really know.
Okay, so I can't. What I do know is I do. No. Skybuster. I've done the Skybuster.
Yeah.
I've done the analysis. I've worked with the experimenters for a measurement of the shape of the Earth. I did the analysis.
You're taking like math equations that someone gave you, right?
I'm taking measurements that somebody gave me.
Exactly.
These were flat earthers actually. They gave me the numbers of the lengths of the shadows. They're just measuring the lengths of shadows of sticks.
Right.
They gave me the numbers. I did the analysis and confirmed that the length of the shadows of sticks was exactly what you would expect if the Earth is a globe, and exactly what you wouldn't expect if the Earth was flat.
Well, so what about the stars? So if we're spinning like they say and all that stuff, how come there's no like movement? How come there's the stars?
How
come it's all?
So if I give you an answer, will you? If I give you an answer, will you believe me, or will you just be like, no, I don't believe that?
No, I take it all in, and until I can physically like.
So why? So have you looked up the answer to this question before? To try to learn the answer, or do you just not care about what's actually true?
Doesn't mean
so wait a minute.
Like me just taking you for granted.
So then you're just not interested in actually knowing the answer to your questions. So are you interested in knowing the answer to your questions or no?
Yeah, I'm interested in knowing your opinion. I'm not going to.
Why you're not? Why if you're not going to believe it? Why do you care about my opinion? Why do you care about my opinion?
I'm not going to turn in the gospel.
Why do you care about my opinion?
Because you wanted to know my opinion.
Look, if your view is that you just don't believe anything unless you've seen it with your own eyes, then like, I'm sorry to tell you, but you'll probably like die of an infection when you're like 55.
Yeah. How old am I?
I don't know. I assume not 55. Maybe you're younger. Maybe you're older. But like, because you can't see germs, right? You can't see penicillin working. So like, presumably you don't trust those things. You don't want to put fungus in your body, right?
I don't trust governments. I don't trust COVID.
What does that have to do with the shape of the Earth? People
Well,
have known the Earth was round for far longer than the United States existed.
Yeah, it's about everything. It's not just the United States. It's
Right,
just
but what government? People have known that the Earth was round before any modern government existed. Before really any government that you would recognize existed.
But but when it comes to the stars and sky, like how come there's no, like when you take a camera or anything, you look up there, you move, it creates a streak, right?
Yeah.
How do stars and light from so far away keep up with us, spinning at what we do?
Well, they don't. They do move a little bit, right?
Okay,
they absolutely
but, like,
do.
they're so far away. Imagine that. Imagine
You're right.
so fast
Because they're
so
hold on, Commander,
further away,
Skybuster.
Yeah.
The further away something is, the less it looks like it moves, right? Imagine you're driving down a highway. Imagine you're driving down a highway, and there's trees on the side of the highway, and then there's a mountain in the back. The trees will look like they're moving really quickly. The mountain will look like it's not moving at all, right? The stars are much further away than the mountains are, so they're not going to look like they're moving either.
I don't know. At the rate we spin it, how far things weigh, it wouldn't be there.
I mean, like, you can actually just do the math, and you'd find that you would expect them to not appear to move.
But we see them flashing.
What stars flash that you see?
You ever look up in the sky?
Are you talking about twinkling?
Whatever you want to call it, I don't care.
Yeah, so twinkling is a result of atmospheric distortion.
Just on certain ones.
Well, on all of them except the planets. The planets are too big.
Oh. How come there's a lot of stars up there? And
How come there's
some of them flash?
So all of the stars twinkle.
Hey,
all of the
well, I take
stars
pictures of them,
twinkle.
And I don't get stars. I don't get what this. I see other objects, actual objects with shade, shadows, and I see in multiple stars, I get the same objects.
Are you talking when you like try to zoom in on a star?
Not like over zoom or under zoom. I'm talking like, take pictures. Yeah, take pictures.
If you try to zoom in on a star and your focus isn't set properly, it'll distort the image and it'll look like a blob.
I get that. I see that, and I see people posting them. And when I go through my camera, I know exactly what they did.
Right. They're
focusing or under focused.
Right. And so if you focus properly, it'll just be a point of light. It'll be exactly 1 pixel. It'll be exactly 1 pixel in size.
Nah, I mean, I don't believe so.
Then you're not focusing properly.
Camera. I mean, some of the things that I can do when it comes down to the little tests and challenges or looking and.
So in order to focus, the way that you can tell if you're focused properly on like any object, whether it's like on the ground or in the sky or whatever, is you focus until it's as small as possible, right?
Yep.
You adjust the focus until it's as small as possible. And when you do that with a star, you'll end up with a single point of light.
Yeah, and when I do that, then you zoom in on that photo.
So when you zoom in on a photo that's already at your max resolution, of course it's going to look blurry. Of course it's going to look pixelated and stuff. You can't zoom in on a photo that you've already taken. You know that, right? Especially if it's digital.
Why?
Because the digital data is saved discretely. You'd have to like run an algorithm to enhance it, and then you're adding in your own stuff. The data's just not there. Do you think that you can like take a digital photo and then just zoom it in and forever? Like,
no, I'm just saying
because that's what you're suggesting that you can do.
Well, you'd have to see them, but
yeah, you show me. If you have them on your phone, pull them up, make them your back, pull them up and show me.
Figure out how to do this. I don't know.
So press on the little camera icon down at the bottom somewhere around here. And it'll give you an option to turn on your camera. And then there'll be an effects tab. And you get like the effects tab will pop up. You can click on that, and there'll be a thing that looks like a green screen, and then you can select the image.
I'm working on it.
Okay.
I'm just like, I almost died a couple years ago, and ever since things don't seem the same. You know, you see evil and good inside everything.
Okay. Thanks for being here, Skybuster. I don't want to do that. No. Don't want to do that. Good luck, Skybuster. Hey, how's it going? tinyurl.com/ohguestbox. Can you hear me?
Hi. Yeah, can you hear me?
Yeah, I can. Do you think the Earth is flat?
Kind of, but in the most roundabout way. Good morning from here in California, by the way.
Likewise. What do you mean by that?
Okay, so the Earth itself, not flat, but if you're going about it in the most roundabout way as possible, due to the holographic principle, the entire universe.
Get out of here. Get out of here. None of that. All right, Guestbox is currently empty. One of my trolls, I'm fairly certain that this person is my troll, so I don't really want to talk to them. Actually, you know what? I could just get their IP address. And I can just verify that they're my troll. One sec. Okay, yep, this is my troll. Goodbye. I don't want to DDoS anybody, I just gotta double check that it's my troll. From Garba Gaiman with the 5 Canuck bucks, saying, sadly, a couple days ago, NASA was reclassified to an intelligence agency. Bummer. Bummer. Yeah, if somebody joins on my background here, yeah, I can have your IP address. My IP address is also open. Which is why I use a VPN. Because then you end up with trolls like that. Otherwise, you end up with trolls like that. So yeah, it's safest to join through TikTok, but if you don't want to join through TikTok, then use a VPN or something. Let's bring on Canadian Fair Enough. All right, this person is not connecting. Snowy Cactus, how's it going?
Hi, I'm good. How are you?
I'm doing all right. Are you over 18?
Yeah.
Okay, do you think the Earth is flat?
I personally don't, but I do have a question from the opposing side. Like, if you could explain one of their...
Well, there's nobody in the guest box, so I will allow it.
Okay. So, I saw this one video of this guy who... I mean, I feel like the answer is obvious, but I was wondering if you could maybe extrapolate on it. He went on an airplane and used like a level and like did some math to prove that there was no curvature in the flight, which then proved the Earth was flat. But I'm wondering...
Yeah, so if you use a level while on a plane, and the plane is tracking the curvature of the Earth. So the way a level works, like the bubble levels, right? The one that you like lie on the ground, there's like a little bubble, that kind of thing.
Yeah.
So the way that those work is they track what direction gravity is in, and then so if the bubble's in the middle, that means that your thing is perpendicular to the direction that gravity's in. So if your plane tracks the surface of the Earth, gravity is always pulling downwards from this, downwards in the direction of the plane because you're tracking the curvature of the Earth. And so the bubble will never move even if the plane is going around the curve.
Well, I understand that, but what I wonder is, how far do you have to go before, or how would they detect curvature of the Earth if
You can just take a picture of it.
Well, I mean, like if you were to like put it into a mathematical format, would you be able to, like, how long until you see a big difference of curvature within the Earth if you're traveling from point A to point B? I guess how do they calculate that? If you could.
So it curves by 1 degree every 69 miles.
Oh, okay.
But like a level on a plane won't show you that because the level is tracking the direction that gravity is pointing, and gravity is always down if you're going around the surface of the Earth. So a level won't tell you that.
Do you have a, I guess, a shorthand way, and besides the, you know, you said 1 degree every 69 miles? What's the sort of way, is it, you know, mapping the stars? Just sort of
You could, this is one way that you can do this. So if you look where Polaris is, the North Star, what you'll find is that if you go south, say you're in like, I don't know, New York or whatever, or let's start somewhere where you can drive. So let's say you're in Montana, right? If you're in Montana, which is pretty far north, the North Star will be, I don't know, 40 degrees above the horizon or something like this. I don't know what latitude Montana is at. Montana, so it would be, so the North Star would be like 46 or 47 degrees above the horizon, depending on where you are, in Montana. But every 69 miles you drive south, it will drop by 1 degree.
Okay.
And that's like pretty unexplainable if you're a flat earther.
Yeah, that was my one thing. You know, I sort of thought it was laughable that he put a level on there, but I don't know, there was something.
Yeah, it was.
That, but yeah, I don't know. I'll let someone else come up with, you know. But thank you for explaining.
Of course, sounds good. Take care. All right, let's see if there's anybody else in the guest box. There's nobody else in the guest box, and what that means is that we're probably gonna end live because I'm hungry, and you know I need some coffee. I have a headache, so. All right, y'all. We've done it. We've defeated the flat earthers. We've destroyed the flat earth is dead. This is it's over. We're finally done. All right, y'all. I'm going to end the live. Before I do, if you want to join the Discord server, you don't have to, but if you're 18 plus and want to join the Discord server, and you want to get like announcements about like when I'm going live or when I post a new video, or if you just want to like ask questions and talk with like-minded people, there's a link in the description of the YouTube video if you're watching on YouTube. There's also a link in the link tree in my bio if you're watching on TikTok. You'll have to copy and paste the link from the link tree in my bio into a browser because for some reason clicking the link doesn't work. Anyway, you should join the Discord. However, if you don't want to, that's okay. It's just a neat place to be. On the other hand, I will be live tomorrow, not for some debates, but instead we will be live for Ask a Physicist. So if you have physics questions, make sure to come tomorrow, whether on YouTube or on TikTok. Ask away, and I will be happy to answer them. All right, y'all. I'm going to end live. Take care.